APIs have become the backbone of software development, making API testing an essential skill for developers and testers. In this course, Valentine Despa will teach you how to use Postman to write and automate API tests. From the fundamentals of API testing to the intricacies of automating these tests using Postman, this course covers it all. You will learn about variables, scripts, debugging, JavaScript basics, JSON format, assertions, regular expressions, and more. Plus, the course provides valuable insights into integrating Postman tests in CI/CD and the fundamentals of collaboration within a Postman workspace. So, let's start learning.
Hello FreeCodeCampers, and welcome to this course introducing you to API testing and automation with Postman. My name is Valentine. I'm a software developer with a passion for sharing my love for technology in a fun and easily digestible way. In this course, we will dive into why automated API tests are so important and how Postman can help with that. My goal is to help those already familiar with creating requests in Postman explore the thrilling world of test automation with an emphasis on writing tests and automating test executions. While this course is for beginners, it is not for absolute beginners in terms of APIs. You will get most value out of this course if you already know what an API is and know how to use Postman to create requests. If you are a total API rookie, fear not, FreeCodeCamp has at least 2 other courses to help you get your feet wet. Now let's turn our attention back to this video, which wouldn't have been possible without the support of Postman, the sponsor of this course, for which I am very thankful. Throughout the course, we will work with an existing Postman collection, write tests, and automate their execution with various tools by scheduling runs directly from Postman or by employing a third-party CI/CD tool such as GitHub Actions. In other words, we'll be focusing on test automation. If you ace all the assignments from this course, you will be able to claim a Postman badge that certifies you have completed this course and are a true pro in test automation. Want more details? Check the video description for a link to the course notes. There you will find essential resources and troubleshooting tips for when things go haywire. I will also be posting any updates or corrections there. After all, this is a fast-paced industry where change is the only constant. So if something's not working, make sure to check the course notes first. This action-packed course will surely keep you busy for a few days at least. As always on FreeCodeCamp, please help us create awesome content by liking and subscribing. And hey, if you're enjoying this course, do me a solid and drop a comment below. I'll do my best to answer. If you learned something from this course, I invite you to check out and subscribe to my YouTube channel, link in the video description below, which is packed with content about Postman, DevOps, software development, and testing. Also, don't be shy, connect with me on social media. I'll love to hear from you. Don't forget the sponsor of this course, Postman. Their channel is chock full of valuable videos, definitely worth a subscription, so be sure to show them some love as well. Lastly, a huge thank you in advance to those who will support FreeCodeCamp by clicking that thanks button and making a small donation. I hope you're excited to learn more about automated API testing in Postman, and with that being said, let's get started. Welcome to the world of API test automation, where we're about to embark on an epic quest full of surprises, challenges, and most importantly, fun. I want you to think about this course as a multi-level game, where we'll conquer each stage together and level up our Postman testing skills. To be a pro at this, you need to go through 4 levels, which will take us from manual testing all the way to automation. We are at level 1, where we'll use our trusty Postman collection for some manual testing. We will also need to get up to speed with some JavaScript concepts, but don't worry, I'll try to make this as easy as possible. The first thing I need you to do is to open Postman. For this, I'm going to use Postman on the web. So it's essentially Postman in your browser. If you go to postman.com and log in, you should see something similar to this one. So in this case, I'm logged in inside my Postman account. and I can manage here workspaces and collections. And you can see here that I'm logged in because I'm getting this nice icon here. The first thing that I like to do when using Postman is to change to a darker theme. So from settings, I'm going to select here themes, and I'm going to select the dark theme. Okay, this is just a personal preference. You don't have to do it, but I'm going to use this throughout the course. Now, once you have Postman open and you have logged in into your account, we can now jump straight into the API. Open the course notes from the video description. So in the video description, you will find there a link. Click on that link and you will be taken to a page that looks like this one. Locate the notes for this lecture, and then you will find a link that takes you to a workspace. This is the workspace that we will use throughout the course, so it's important that you know where to locate this link to the workspace inside the course notes. What we have inside this workspace is the collection for an API, as well as various assignments that you will need to do throughout the course. This is the Postman collection for an API named Valentino Artisan Coffee House. I love coffee, so why not create an API for a fictitious coffee place? This API helps browse a list of products, view details, and place an order for coffee. Of course, in order to work with this API, all we have to do is expand this collection here, and we'll see here various endpoints that we can use. For example, we could use this request to get a status of the API. As you can notice here, everything is grayed out and we cannot make any changes to this. To make changes to any of the collections in this workspace, we need to make a copy. In Postman, we call this a fork. So essentially, in order to work with this collection, we need to fork it. Now, before we fork this collection, it is best to create a separate workspace that we will use throughout this course. So from the workspaces here, you will have here the possibility of creating a new workspace. I'm going to name my workspace freeCodeCamp API Test Automation with Postman. And I'm going to go ahead and make this a public workspace. Let's go ahead and hit that Create Workspace button. So we need to switch back to the workspace. And to do so, we're going to need to access that link that we have used previously. So we need the link that we have used previously so that we go to this original workspace with all these Postman collections. Next, what we will do, we will go to this collection, which holds the API. And from the ellipsis, I'm going to click on it, and we're going to get here this menu. And the option that we're going to select is Create a Fork. Now, when we select Create a Fork, there are still a few steps that we need to take. First of all, we're going to be asked how we want to label this fork. And by default, Postman will give us a suggestion, and we can just go with that suggestion. It does not matter so much at this point. The next thing, which is maybe a bit more important, is where we're going to create this copy, this fork of the collection. And we have previously created a new workspace, so we're going to select that workspace. So instead of my workspace, I'm going to click on it, and I'm going to select here freeCodeCamp API Test Automation with Postman. Next, you will be asked if you wish to watch this collection. Watching a collection means getting notifications each time a change is made in the parent collection. So if you don't want to be bothered with emails every time I change something about this collection, it is best to uncheck this. Let's go ahead and click for collection. Now we have our own copy of this collection. So for example, if we expand it here and go here inside the status folder, we can click on Get API Status, and we'll be able to see here that Send is enabled. This is essentially a regular Postman collection where we can start making changes as we need. It is totally independent of the previous workspace we have seen. It's just a copy of the collection we made from that workspace. So let's go ahead and simply click on this Send button to see if this API is working. So what we'll see here is the message API is up and running. If you don't see this message, if you see at this point some errors, no need to freak out. Just refer back to the course notes and follow some of the troubleshooting ideas that I will list there. But if you're seeing this message and we're also getting here a status 200 OK, you are on the right track. A Postman workspace is essentially a central point where collaboration occurs within a team. We will use Postman workspaces to see run results, write comments, and generally collaborate when working on APIs. Before we continue exploring Postman, let's first understand what API testing is. API testing is a type of software testing that checks the functionality, reliability, performance, and security of an API. In simple terms, we test the API to make sure it works as it should. API testing is like quality control in a car factory. A car must go through various inspections and tests before it is considered ready for the road. We really don't want to release a car that has no brakes. Ouch. API testing focuses on examining the API from the viewpoint of an external user, the consumer of the API, to ensure it behaves as expected. The main goal of API testing is to find issues and defects in the API, ideally before it is released and made available to users. In this course, we will focus on functional testing. In functional testing, we will examine if the API works as it should from a functional perspective. And we're going to look at individual API endpoints and ensure that they respond correctly to various HTTP requests. Other types of testing, such as performance tests and security tests, are outside the scope of this course. Before we can automate the testing of the API, we first need to do a manual test. We cannot automate something if we don't know how to do it manually. In this lecture, we'll go through all the endpoints of this API and check if they work as expected. The idea of this API is pretty simple. We have essentially a list of products that the coffee shop has available, and we can submit an order for one or more products. We're going to begin here with a status endpoint because the status endpoint tells us if the API is available, tells us if the API is up and running. So if this endpoint isn't working properly, testing the rest of the endpoints doesn't make a lot of sense. And when we're doing this test, what we want to do is, first of all, send a request, see if something comes back in the first place. And then when something comes back, we're going to take a look here at the status. We typically expect status 200 OK. And second of all, we also want to take a look in the response body and see what's inside there. So obviously, this is coming from the API. It's telling the API is up and running. So this is already a good sign. It tells us we have reached the API, and this is a response from the API itself. The next step is to take a look at the products that are available. So I'm going to expand here the products folder. I'm going to click on Get All Products. You can also go ahead and close this previous tab as we don't need it anymore. I'm going to click here on Send. So what we're going to get here is something a bit more complex in terms of the response. We're going to still see status 200 OK. And we're going to get this relatively large response body that you see here. So we can scroll through it and we're going to see here lots of products, coffees, and so on. Now, there are a few things I want you to notice. First of all, we are getting here 33 results in total. So this is some information about all the products that are available. And these results are paginated, meaning they're not displayed all at once, which means that if we want to go through all the products like the pages in the book, we need to turn the pages. So in order to facilitate that, we also have some information. We know what is the current page, and we know how many pages are in total. So for example, if we want to go to the second page, we need to use a query param. So we'll see here, the params are already available. The params tab is already selected. And one of the query params that we need to set is the page. So if we enable this query param, it's going to tell us the page that we want to fetch. the default initially is 1, but we already have page 1. So let's go ahead and change this to 2. So now we're going to check if we have page 2. So we are now getting other products in the list. And we can go on and so forth through all the pages. Apart from this, what I want you to notice is that each product also has a category. So there are a few categories. For example, let's say we are only interested in pastry. So what we can do is copy the value pastry from here. We're going to disable the page initially, but this time enable the param category. I'm going to paste here pastry. And what we're going to get back are only the products that are from the pastry category. We're going to see here the information has updated. There are 7 results. There's only 1 page in total, and we're getting this page. So if we go and scroll through this, we're going to see that all the products that appear here are from pastry. Right, so this is how we can get a list of products. But let's say, for example, we want some additional details about this croissant. So in that case, we have a separate endpoint, and that is the get single product endpoint. Now, what happens with this list is that a product can have a lot of information, and we don't really want to display all that information at once. For that, we're going to use the get single product so that we get information about a single product. Now, I want you to notice a few things here. So we have the base URL, and then we have /products. And then we're using this annotation which denotes a path variable. It's essentially something that's part of the path, is the address where we can reach that particular product. So let's say, for example, we have here this croissant and we want to get some additional information. So I'm going to go ahead and copy the ID of this product. I'm going to go to get single product and paste this ID here. Let's go ahead and click on send. And of course, what we expect here is, the name is the same. The ID is the same. We're still in the category pastry. But additionally, we're going to get information like a product description, which wasn't available before. Or in this additional text, it's going to tell us, it contains gluten and milk. All right. So now we have tested these 2 endpoints. We have tested that we can get all the products, and this endpoint also has some parameters that we can toggle on and off and play with them. It seems everything to be working fine, so we can just leave it as it is. And then we can move forward. Now, in order to move forward and place an order, there are a few things that we need. But let's go ahead and open the orders. And this time, to create an order, we're going to use a post request. Now, what's important to know about a post request is that the post request typically has a request body, something that we didn't have before. So far, we were like, give me information about all the product. Give me information about a single product. So it's like get me that information. But now I'm saying, no, I want to place an order. So for that, we're using a post request. And essentially in the body, we're saying what we want to order. So let's take a look at the body that is already here. And you'll notice that there's some information that's already entered here. Now, what's interesting here is that we need a customer name. So for example, when you're ordering coffee somewhere, you're going to ask, what's your name? So that I know to call you when your coffee is ready. So we need some customer name. And what we have here is a random Postman variable. A random Postman variable will generate, in this case, a full name with every request. And it's not something hard-coded. Like, for example, if we would write here Jamie Doe, that would be a value that is hard-coded. This is something that changes with every request. And we're going to take a look at that a bit later. But just in case you're wondering, this is the syntax for one of these Postman random variables. And apart from this, what we have here are the products that we want to order. So when we want to place an order, we need to specify the products, and we need to say which is the ID of the product and what is the desired quantity. All right. So let's go ahead and submit this order and see how it works. I'm going to click here on send. And what we're going to get back here is 403 forbidden. And apart from this, we're going to get also this error invalid API key. Now, this is a bit interesting because this is not necessarily what we have expected. We wanted to place an order, but it does not look like this order has been successfully received on the other side. And similar to this, we also have other endpoints. For example, if we want to check what are all our orders that we have. Again, 403 forbidden, invalid API key. Now, the question is, how does the API know who we are? And how can an API then show us all the orders that we have? We need a way to authenticate ourselves, and this is a bit the topic of the upcoming lecture. But in conclusion, we went through some of the requests in this collection. We have inspected the status code to determine if the call was successful, and we also looked inside the response body to see the data that is there, to see if that data actually makes sense. This is a very basic form of testing. We have manually tested if the API works, which, as I said earlier, is a very important step towards automation. So how can we get this request to work? We need an API key, which we don't have, and without it, we cannot send an order. Well, in order to get that API key, we need to register ourselves with the API. Now, in order to do that, we're going to go here to the clients folder, and we're going to register a new client. Now, in the context of APIs, when we're talking about clients or API clients, we refer to entities that are using the API. A client in this context is not the same as a customer. So, for example, for this coffee place API, we wouldn't have the customers actually register themselves with the API. We only need their name in order to process an order. But what we would like to register as a client is, for example, a terminal where an employee types in this information. In a more general context, your Postman tool and your usage against this API is also a client. So when you are using Postman to connect to this API, Postman is a client. It's an API client that connects to it. So we need to register ourselves with this API. Now, again, this is a post request because we're creating some data. And whenever we're creating some data, we're also sending this data typically here in the body. What we have here for the registration is an email. We only need an email to register ourselves. Now, again, here to test various scenarios, we have a random email that's being inserted here. So this is absolutely the same as writing something like jamie.doe@example.com, but Postman changes this all the time with a different value. Not so relevant at this point because we just want to register ourselves with this API. So let's go ahead and click the send button. And what we're getting back this time is 200 OK. And what we'll see here is a token. Now, token is sort of like a temporary password that's being used by APIs. And if you're working with APIs, we're going to come across tokens a lot. Now, what's important about these tokens is that this is a secret. This is something that only we should know. And we want to make sure that we handle this secret in a very careful way. In Postman, what we don't want to do is we don't want to put this secret inside the request. We want to store it somewhere else where it is a bit more safer, a bit more protected. Remember, we have created here a public workspace. If we put here a secret somewhere in our request, well, somebody else can just simply grab that secret and impersonate us. This is something that we don't really want to do. Now let's go ahead and copy this value. And what we're going to do with it is we're going to store it inside our collection as a Postman collection variable. I'm going to hover here over the collection until this ellipsis shows up. I'm going to click on it. I'm going to select here Edit. And this will open up information about the collection itself. Now, what we can do next is to go here to the Variables tab. And what we'll see here is already an entry, API key. Well, apparently we need to enter here an API key, and this API key will be used by the collection. So obviously, enter a valid API key is not an expected value. So what we're going to do is we're going to go here under current value. We're going to paste the value that we have received when we have registered ourselves with the API. And next, I'm going to click here on Save. It is super important that you understand the difference between the initial value and the current value. Because our workspace is public, somebody else can see this information. But from the outside, the only information that is visible is here the initial value. In the initial value, our secret API key is not being exposed. However, when we're running a request with Postman, only the current value is being used, not the initial value. So this token that we have here can be stored even in a public collection and can be used by us when working with Postman and sending requests, but others from the outside cannot see this information. So in a nutshell, it is always a good practice to store any secrets that you have in Postman variables and to make them part as the current value unless you want to share them with others. So now we have stored this value. So let's take a look at create a new order. Why didn't this request work? Well, actually, it has a bit of authentication here, and the token that we have provided previously is not valid. So let's try this request once again to see if it works now. So now what we have here is actually status 201 created, indicates this order has been created. We're saying, okay, great. Let's take a look at the response body to see what we have inside there. And we'll have here the order ID. This is our client ID. So this is some internal ID that the API has assigned to us. We know when this order has been created, and we also know the customer name. And you're probably wondering, well, where this Amy came from? Well, this is the random full name that at the time of the execution, Postman has simply generated this random name. We submit this request once again, we're going to get a different name. And then in the lower part, we also have the products that we have ordered. Still, you're probably a bit confused. Where does this come from? How does this work? Well, typically authentication is being sent either as a query param. So if you look here at the params, you're going to see, no, there are no query params. Okay, so if it's not a query param, typically it is something in a header. So we can take a look here at the headers. And again, we're going to be, no, I don't see anything. Oh, well, let's take a look again. You see here, we have 10 hidden headers, right? So let's click on this to expose these hidden headers that we have here. Let's take a look if there's anything that we, oh yeah, look at this. X-API-key. So this looks maybe like our API key that here. So how did our Postman variable transform in this header here? That's a bit weird, right? And, how can we change this? If you're trying to make some changes to it, doesn't work. Okay, so this is a bit of the magic of Postman, trying to make things a bit easier for you to manage. But, if you're encountering this for the first time, it can be totally confusing. Actually, this has been configured using an auth helper. The name implies it's something that's designed to help you a bit. And this is typically configured under authorization. If you go here under authorization, what we're going to see here is, well, the type is inherit auth from P. It actually says parent, so it's just a bit smaller on my screen. So it means do whatever the parent does in terms of authorization. It's like, oh, which parent do you mean? Well, as you can see, this request is inside a folder which is called orders. So we need to look inside the orders because that's the parent. All right, so we're now inside orders, and what do you see here? We have authorization. This is the tab where we're active. And what we have here in the list is API key, because yes, we have an API key. And in this case, the API key has a key name, which we saw in the headers, also has a value, which this is how we reference the Postman variables with curly braces. And then this is added as a header, and we actually saw the header. The advantage of configuring this on a folder level is that all the other requests that we have can use this without us having to manually go through every request. So let me show you, for example, if we go here to get all orders, we expect here to see the order that we have just submitted. So what do we see? Status 200 OK, looks good. And here is our Amy ordering something from the API, ordering something from the coffee place. Perfect. So as you have seen, nothing has changed. Just by placing a Postman variable in the right spot and correctly configuring this request in terms of authorization can get things to work again. Now we still have one endpoint, and that is get order by ID. So you can simply go ahead, and we already have here an ID. Let's go ahead and see if this works. No, we're getting back 404 not found. Well, typically 404 not found can mean two things. Either this order really doesn't exist, or actually not our order. So if we're looking here in the list of the orders that we have, well, we have a different order ID. So how about we use that one and replace the value here? Let's click send again. And yes, we're going to see here the entire order that we have submitted, including the products that were ordered, which were previously not visible. So in a nutshell, this is how we want to handle secrets in Postman, by using variables and also using these auth helpers, which make our life a bit easier and also reduce the chances that we make any mistakes. We need to be able to write scripts in Postman to automate the testing of this API. API tests are written using scripts. And automated testing is a way to check if the API works correctly by letting Postman run some tests instead of running all these requests by hand and checking the status code and checking the body and so on. This approach has many benefits. Most importantly, it is faster and more accurate because a computer can run the same tests over and over without making mistakes. Computers are great at this. Humans tend to get bored and start making mistakes. Writing tests also helps document how the API should behave, or how it used to behave in the past at least. Now, leaving all the benefits behind, let's actually start writing some scripts. But where can we do that? Well, let's expand here the status folder and get into the API status request. In Postman, there are two places where we can write scripts. The first one is the pre-request script, and the second one is inside the test. Now, what does pre-request script mean? Okay, it is a script. Well, pre-request means that this script is executed before the request is being sent. And we're going to get a bit into that, why this is important and which are the use cases. But just keep this in mind. You can write them before the request is executed, and inside the test, you can write some scripts that are executed after the request has been sent and a response has been retrieved. So how does this look like? Well, if we click inside the pre-request script, we're going to have here this editor where you can start writing some code. The same goes here for the tests, pretty much the same editor. So this is where we can write these tests, inside this editor here. In order to write the tests here, we need to use a programming language called JavaScript. Postman only supports JavaScript, and it is not possible to use any other programming language to write these scripts. However, JavaScript is relatively easy to learn, and also in the upcoming lectures, we're going to go a bit into JavaScript. So if you've never written JavaScript before, it's absolutely fine. I'm going to take you through this step by step, no worries. Some people confuse JavaScript with Java, another programming language, but trust me, they are super different and they don't have anything in common apart from this, let's say, unfortunate naming similarity. But anyway, just keep in mind, JavaScript and Java, definitely two different things. All right, so how do we write some code? Well, let's go ahead, for example, and start with what we do in a lot of programming language. We start writing like a hello world thing. So how do we do that? Well, we can start typing here something like console.log. You will notice as I start typing, you're going to get these suggestions. So if you hit enter, it's going to autocomplete with the first option that you see in the list, that is console. I'm going to write here dot, and there another suggestion pops up, and I can even go and select what do I want to use here. So if you start typing log, you're going to get only one suggestion, and if I hit enter once again, this suggestion will be completed. This is just a quicker way on how you can type this and make sure that you're making fewer mistakes. All right, so console log is something that allows us to print a message. So I'm going to go ahead here and between parentheses and single or double quotes, I'm going to write something like hello from the tests. Okay, so this is the message that we want to send out. And at the end, we're going to terminate this instruction with a semicolon. In order to actually execute this code, we need to click on this send button so that we run the request. This code is always associated with the request itself. So either we decide to run this code after we have executed the request or in the request script before we have executed the request. In this case, it is in the test, so it's gonna be after the request has been sent and the response has been retrieved. So let's go ahead, send this, and we're not gonna see anything. However, what's important here is that we are not noticing any errors. If there were any errors, we'd see them here in test results. So for example, let's replace log with a capital L-O-G, just to make fun of this. So console.log, gonna send this, and we're gonna get here an error. Now this can be super scary when you're encountering this. So in JavaScript, it's always important how you write things. So things are always case sensitive with APIs, with programming. You want to make sure that you write things exactly as they are. So in this case, we're gonna get an error. But if we write everything correctly, we're not gonna see anything. And this is because things are gonna be printed to the Postman console, which is the topic of the upcoming lesson. If you're writing scripts in Postman, there is a Postman tool you absolutely need to know and use, and that is the Postman console. So let me show you how to use the Postman console to debug your scripts, understand your requests, and many other things. So in order to open the Postman console, we'll have to go here on the lower left corner, and you will see here console. So if you click here on console, this additional window will open up. You already see here a lot of requests. Now, first of all, we don't need everything that is already here. So we're gonna go ahead and click on this clear button. Now let's go ahead and submit this request once again, where we have this console log script. So what we'll see here in the Postman console are two things. First of all, we'll have here the request, where we're requesting some information, and we can expand this. And we're gonna see here request headers and other information from the response body. So there's a lot of information about the request that has been sent. What's important to know is that everything that appears in a console is in a chronological order. So it appears as it happens. Now we have this script console log, and because we have written the script, we are getting this message in the console, hello from the test. Because this is inside the test, we are getting this message after this request has been sent. Let's say, for example, that we want to display a message before the request is being sent. So I'm going to copy console log, I'm going to go here to the pre-request script, and I'm going to paste the exact same code. But this time, I'm going to write here hello from the pre-request script. And I'm going to hit again the send button. And what we'll see here is that appended to what we already had in the console, we now have hello from the pre-request script, because this is being executed before the request, then the request is being sent, and only then hello from tests appears here in the logs. Let me show you a neat thing about this. The thing is, when we're working with the Postman console and we're sending a few requests, this entire log here will get really crowded with a lot of messages. So instead of manually clicking on this clear button over and over again, we can do a different thing. So here in the pre-request, I'm gonna write here console.clear. And I'm also make sure that I'm gonna add here the parentheses. So what this will do is will clear the console with every request. So let me show you what I mean. I'm gonna click here again on send. You're going to see here, console was cleared, the request is being sent, and then the code that is in the test will be executed, and we'll see this here. We're going to work with the Postman console a lot, so it's important to get familiar with it, write this code, understand where it appears, understand in which order this code is being executed. If you no longer need the console, you can simply close it from here, and if you need it again, simply click on it again, and it will appear here. In this lecture, we're gonna write our first API test in Postman. And actually, we're going to get a bit of help from Postman, but just wanted to get the taste of what is an API test so that we don't talk so much about API testing and actually start writing some. So I'm here inside the get API status request. I've opened up the test tab and we already have here this console log message. And we can continue writing here code. But what kind of code are we going to write here? Well, let's say that we want to assert, we want to check, we want to test if for this request we're getting a status to 100 okay, meaning the API is answering back and saying, hey, the status is okay, everything is good, you can use this API. And we don't want to do this manually. We don't want to look at the status code. We want to forget that there's a status code. We don't know anything about it. We want to write a script and want to let Postman do this for us. How can we do that? Well, in that case, what we can do here in Postman is that we can open here a panel. So it's a bit hidden here on the right-hand side. If it's not already expanded, you'll have to click on this. You will get here a list of snippets. These are useful scripts that you can use. If you don't see the snippets, don't worry about it. I will also include the exact same code that I'm using in the course notes for this lecture. Now, if you can see the snippets, all you have to do is scroll a bit through the snippets until you find here something that says status code is to 100. Okay, now before you click on that, I want you to go here in the code editor, hit enter 2 times so that we are here on line 3 now. Now you can simply go over status code is to 100 and click on it. And by magic, this code will be generated. Okay, now this code is written in JavaScript, but it also contains like a language that is easy to understand. So we have a test name which says status code is to 100. That's pretty easy to understand. And then we have here something that says pm.response to have status to 100. This is essentially the assertion that we're making. We're checking if the status is to 100. So let's run this code again by submitting the request and see the difference. Now, because we now have this test, we are seeing here on the lower part of Postman test results. So we can click on this, and what you will see here, we're going to see that we have different tabs for all passed, skipped, and failed. Essentially, it's going to tell us all the tests that we have here for this request, and we have only one test, status is to 100. It says here, passed, right? It's even indicated here in green, 1 from 1 test have passed. So this is the difference between us manually checking if a status is to 100 or writing some code and then checking here at the end, has everything passed. And we only have one test, so obviously the difference is not so major, right? You can easily tell if it's 200 or not. But let's say, for example, what if we had here 5 tests or 6 tests, right? Postman can do this in an instant and tell us if all the tests that we have written pass or not. Now again, what we have here is JavaScript. And now in the beginning, it may look a bit weird, right? So the thing is, we will look into better understanding JavaScript so that we can write this kind of tests on our own. But I just want to show you how easy it is to write your first test. There's one important thing that I want you to take from this. Even if we have used Postman to quickly generate this code and we don't exactly understand what it's doing, it's important that we ensure that this code is working. So how do we ensure that this code is working? Well, by generating a status code that's not to 100. So in this case, what we can do here is we can write here status 2, for example, which is an endpoint that doesn't exist. So when I'm sending this request once again, against status 2, I'm gonna get back here 404 not found. And if I'm looking here at the test status, I'm gonna see 0 from 1, fail. So this indicates that Postman has executed this code which has a test and has checked, is the status to 100? No, it's not 100. Then, bam, alert, it's not 100. It's reporting this information here so that we can easily see it. We are starting to automate this, and you're gonna get a taste of it real soon. So we have created this code here by simply clicking one button. However, we don't fully understand what exactly is going on here. How does this code work? and how we can write maybe more advanced tests. So to be able to understand this code, which is written in JavaScript, and even write more advanced code, we need to learn a few JavaScript basics. In the upcoming lessons, we will cover some of the most important concepts in JavaScript that are relevant for writing API tests in Postman. We will cover JavaScript variables and their scope, data types, including objects and arrays, functions, and many other things you should know. Now, keep in mind that this is not a full JavaScript course, and always check the course notes for additional resources and learning. However, with what you will learn in the upcoming lessons, you should have just enough information to get started writing code in Postman and understanding such code if you see some. One of the fundamental building blocks of any programming language, including JavaScript, is the concept of variables. In this lecture, we will learn about the JavaScript variables, their declaration, types, and how to use them in our code. Variables are like containers that store data for us so that we can use them to store and manipulate information in our scripts. You can think of a variable like a jar. In a jar, you can put something and then put a label on it so that you know what's inside. So for example, if we want to store a name like Jamie, that's the data, all we have to do is put Jamie in a jar and put a label on that jar, which is like first name or simply name. So let's do exactly that in Postman. First of all, I'm here inside the test script. So I'm going to go ahead and remove everything that is inside here. And in the pre-request script, I'm going to keep here console clear because that's going to be useful. Apart from this, because we're going to be focusing on scripts, I'm going to change a bit the interface of Postman. First of all, I'm going to collapse this panel here. So there's an option here right at the bottom, hide sidebar. This will give us a bit more space. And additionally, there's a different way on how we can organize everything in Postman. And one of this is this side-by-side pane. So we have this two-pane view, which we can click on it. And it will move here a few things to the side. So we'll see here the test results and everything. But this is something that we actually don't need. So we're going to move this all together. And we're going to also collapse these scripts. So this gives us a bit more space to write this code. And in addition to this, I'm going to open up here the console so that we have here the editor and the console in clear view. Perfect. So let's go ahead by actually defining a variable which is called Jamie. So I'm going to use the keyword let, which is used to define a new variable. So I'm going to write here let, and then we have to provide the variable name, which is like on the jar, the label. So we can say here name. And then I'm going to use the equal sign. And between quotes, I'm going to put here the name Jamie. When we're working with strings like names or any text or something like that, it is always important to put this between quotes. That this is when we have a string. You can use single quotes or double quotes as you prefer. Now, if we simply run this code, nothing will happen. So it's important to remember that if you want to check what's inside the name variable, then we'll have to use here console log. And what we're going to do here, we're going to pass name. Between the parentheses, we're going to write name. In this case, it is important that you don't put quotes. So let me show you. We're going to click here on send. And what we're going to get back is Jamie. So what is happening here is by not using name between quotes, we are actually referencing the variable name. And then by referencing the variable name, we're trying to log this variable. Well, what's the value of this variable? Well, it's Jamie. Okay, let's write that. So this is why Jamie appears here in the console. It's important to remember that this code that we are executing here in Postman doesn't store anything anywhere. This jar with a label name will be destroyed after the execution of the code. So it's available while we run this code here, but once the execution has stopped, this variable no longer exists. So for example here, I'm going to simply comment this code out. So I'm going to write here //. This essentially ensures that this code is not being executed. It's commented out. And if I run this request once again, we're going to get back here a reference error, which is a JavaScript error, telling us name is not defined. You are trying to log here a variable called name, but name hasn't been defined anywhere. So this is why this code is failing. This is just to demonstrate that this variable only exists during the execution of the code. All right. So now these are the absolute basics in terms of defining a variable and using a variable. So how about we next define two numbers? So let's say I want to define a number which is called a. I'm going to write here a equals 20. And I'm going to define another number called b, which equals 30. As you can tell, 20 and 30 are not between quotes. But if we're trying to put here in console log a, we're going to get 20. There are no errors. This is because 20 is a number. We can even, by comma separating a and b, we can even log a and b together. So we're going to get here 20, 30. So we can see two values at the same time. Sometimes we want to create variables that are the result of some operation. For example, we may want to define here a variable which is called sum and want it to hold the result of adding a and b. So we can write here a plus b. So what we're going to do here, we are going to initialize a new variable which is called sum, but here we're going to have this mathematical operation which adds a and b. So let's take a look here at the value of sum. We can add that to the list as well. You're going to see here that if we're adding 20 and 30, the sum will be 50. The advantage of using these variables is that we can change one of the variables. We don't need to change anything about that code. And then the sum variable will be updated accordingly. So we have here a and b and sum referenced in multiple places, but we only need to update them once. Sometimes we also need to join strings together. Say, for example, we have here a variable which is called first name. And just as well, we have another variable which is called last name. So these are two strings. Now let's say that for this person, we actually need the full name. So we're going to define here a new variable which we're going to call full name. And in this case, full name will be pretty similar to the way we have added two numbers. And you may be surprised by this. But we can use here first name plus last name. So let's see what's happening there. I'm going to change here the console log so that we can log this variable. We're going to see here in the console, Jamie Doe. Now, of course, this is less than ideal because there's no space between Jamie and Doe. But just as well as we have added here first name and last name, we can also directly write a string here. So we can write here after the plus sign, in between quotes, we have here quotes, and then we're going to add another plus sign. So we are combining first name with an empty string and with a last name. Now, in this empty string, all I have to do is press the space bar, and we're going to create a white space. So if we're running this code again, what JavaScript will do is we're going to take the first name variable, take its value, then combine it with a white space. You'll notice here between Jamie and Doe, there's a white space now. And then add Doe. So now we have defined a new variable with a combination of two variables and also something that we added in between. How we write these variables in JavaScript is super important. For example, you'll notice here that first is written in lowercase, but N here in name is with a capital N. If we replace this and have everything in lowercase and try running this once again, we're going to get an error. And sometimes this can be so confusing for beginners. It's like, what do you mean first name is not defined? I've just defined it here. It's right here. Why can't you find it, right? So if something like that happens, always need to trace back to what you have written. And quite often you're looking at the screen and looking at what I'm doing, and it's like, no, it's the exact same code as you, and mine is not working. Now, the reality is that if the code would have been the same, it should have worked the same. But even just one letter, a difference, can cause the code to have such an error, right? So when you're in the beginning, it's always a good idea to simply copy paste things instead of writing them on your own, because some mistakes are a bit hard to spot, and especially if you're not working with these errors and you don't understand exactly what they mean, can be a bit hard. So always, if something isn't working, make sure that you really have everything as you see here on the screen. Now, first name in lowercase and first name with the first letter of each word capitalized, except for the first word, is called camel case. Camel case is a widely used naming convention in JavaScript for naming things, as it makes things easier to read. It enhances readability. So now we are getting pretty comfortable with these variables, and as the name implies, a variable can change its value. Using a variable is super useful because we can change the value as needed. We can change its values during the execution of the script, or we can change it later on. We can reference a value in multiple places without us needing to hard code it, right? So instead of having here full name once again written like Jamie space Doe, you can simply reference all these variables. Now the opposite of a variable is a constant. And once we define a constant, we cannot change its value. So just so that you understand what I mean by changing a value. So for example, we have here first name, and for some reason we decide, first name doesn't have the right value that we want it to have. So we want to make a correction to it. So I'm going to write here John instead of Jamie, right? This is possible. You notice here, I'm not using the let keyword anymore. I'm running this code once again. And then I'm going to see here, we have John Doe, right? So we can change this value when we define it once, but because we have used let, we can change this. Now, let's take a look at the following example. I'm going to replace here, for example, first name, and instead of let, I'm going to use const. I'm going to say, you cannot change this first name, right? And initially the code works absolutely the same. No difference. But when we're trying to enable this line of code, which changes the first name, this time we're going to get an error here. It's like, whoa, what are you doing? It's like, you have defined first name as a constant. You cannot change a constant. And this thing failed. So this is just JavaScript telling you, you told me to take care of this variable and to keep it sealed there in the jar and not allow any changes to it. And now you want to change it? No. This is not possible. Okay. So this is why we have this constant. Now, sometimes it does make sense to use a constant. Other times you don't need a constant. So in this case, it really depends. Maybe it's not the greatest example. But let's say, how about if we have here something like year of birth, right? So let's say I have here a const. We're going to define here year of birth. And we're going to say here is 1995 or 94, whatever. Well, it kind of makes sense if we're storing information about the person. The year of birth is something that we're not going to change, right? So maybe we're going to change the last name for some reason. Maybe we can change other information like an email or address, phone number. But year of birth, that is a constant, right? It doesn't change, right? The same, we can store like how many seconds are in an hour, right? This is also something like a constant, doesn't change. So whenever we have data where from a logical perspective, it doesn't make sense to define this as a variable, then we should use a constant. When we are working with variables in JavaScript, there's an important thing you need to know about, and that is the variable scope. Scope is just a fancy name for like where is a variable available. For example, we already know that this variable name that I've defined here is only available during the execution of this script. The same goes for the pre-request script. If we define here a variable, this is going to be available only in the pre-request script. We cannot reference it in the test script or something like that. And also, if we run this request and define a variable, and we run the request again and try to reference the same variable, that's not going to work because that variable will be gone by then. But still within the same script, so inside the test here, we can still have a scope. So in JavaScript, we can define another scope, so like essentially another area where we can define variables. and this is inside a code block. So right now I have defined this variable name Jamie, and I'm using here console log on name, and I'm seeing here the variable being displayed in the console. Perfect. Now what we can do here is put this inside a code block. So I'm going to start here a code block with a curly bracket, and I'm going to end it with a curly bracket as well. So this is a code block in JavaScript. It is not very useful in this concept, but I just wanted to illustrate what it means for code to be defined inside a code block. So if we try here, for example, adding another console log statement, we're just going to get here Jamie. Perfect. But let's see what will happen if we define the name Jamie here. Well, we're going to get Jamie. But what if we change Jamie to Jake? Let's try it once again. And we're going to get here Jake and Jamie. So what exactly is going on here, and why can we redefine this variable if we already defined it, right? We notice here we have the let keyword 2 times. What's going on? Well, these are a bit the rules of this code block. So what this code block allows us to do is to define our own variables in the code block. So in this case, we have here what is called the global scope. We have a variable name, and we are here in the global scope. Then we have a code block, and then we're back in the global scope. So console log will not be able to see what's happening here inside this code block. And we'll essentially say, okay, you're trying to log a variable name. I know here a variable name. I'm going to try and print this out. So the name will be Jamie that appears here. And here inside the code block, we have declared a new variable, which is called name. It is just a coincidence that it has the exact same label, exact same name as the previous variable. But we can just use it here inside the scope. We can make changes to it and so on. So this is why we can see here a variable called Jake, and we're going to be able to access it here. Now let's take a look at what happens if we remove the first declaration of the variable. So we only have the code block. Now if this is the case, what we're going to get here is a reference error. We're going to say here name is not defined. And this is because we are trying here to access name from the global scope, and in the global scope, this variable hasn't been defined. Now, there are a few things that we can do. Let's say, for example, well, we only want to define it in the global scope. Perfect. In that case, what we could do here is we're going to write here let name. And if we remove here the let, what will actually happen is that when we're initializing here name with Jake, we're not defining a new variable, but we're using one from the global scope. So let's see if this works. We're going to get here Jake. So what has happened here, we've defined here a variable, but we haven't set the value. Then inside the code block, we have set the value to Jake. We have printed it. And then because this variable is defined in the global space, we can also access this here. Now, I can totally understand that this can be a bit confusing, but you can think about these code blocks like a one-way mirror in an interrogation room you see in the movies. The cops in the room can see outside, but the suspect cannot see in the room. So this is a bit hard to understand, but if there is one takeaway I want you to get from this lecture is that whenever you're noticing here a code block, pay close attention to variables and understand where they have been defined. And I'm going to point this out also later in the course, but this is something that tricks a lot of people, and they don't understand where exactly is a variable defined, why do I get a variable undefined error, and similar things like that. So we're going to start working with this, but in this lesson, I just wanted to introduce you to this concept so that you can start getting familiar with it and notice when this is the case. So in a nutshell, in a scope, we can define some variables, and nobody from outside will be able to see what's going on inside that code block. Gonna keep it like private, like what's happening in the code block is only what is behind the one-way mirror. But what is happening here in the global space, this is something that is public knowledge for everyone. So we can read it in the global space, but if we need access from the code block, we can also see what's going on there. In JavaScript, there are a variety of data types that are needed to represent information. This lesson aims to provide a basic understanding of the JavaScript data types you are most likely to encounter when writing scripts in Postman. These are strings, numbers, booleans, objects, and arrays. By understanding the usage of these data types, you will be better equipped to use them when writing scripts. So far, we have interacted with two data types. We have worked here with strings. For example, in this case, we're initializing a variable called name with the string Jake, and also number, and you'll notice here that numbers are not between quotes. If you're not sure about the data type of a particular value, JavaScript is there to help you. So let me show you. For example, we can use console.log. And inside console.log, we can use the keyword type of written together. And this will give us the type of whatever we provide after this. So for example, if you're trying to get the type of name, let's go ahead and see that. We're going to see here, we're getting string. Just as well, instead of referencing a variable, we could simply write here something like Jamie, and we're going to get back a string. We can write here 29, and we're going to get back also a string. Well, the thing is, 29 is between quotes, so anything that is between quotes, even if it is a number, it would still be a string from a JavaScript perspective. So now to make it a string, to make it a number, we'll have to remove the quotes. Run this once again, and we're going to see this is a number. Okay, perfect. So we are kind of like understanding a bit how things work. If a number has decimals, we can write them after the dot. So for example, we can have here 29.65, and this will still be a valid number. Sometimes we need to represent the state of something, like on or off, like a switch that can only be on or off. Well, we could theoretically use a string for that and say on, off, but JavaScript has a data type called Boolean. A Boolean value can only be true or false. So let me show you, for example, let's say here that we are going to create a new variable, and let's initialize it with isAdult. And we're going to set the value of true. If we want to check the data type of isAdult, all we have to do is use our console log statement here and run this. And what you're going to get back here is Boolean. Super important. True and false. To be a Boolean doesn't need any quotes, just like with a number. If we put anything between quotes, it will become a string. Another data type that is maybe a bit hidden and sometimes confusing is undefined. So this is something that can confuse a lot of people. So let's do, for example, the following. We're going to define here a variable isActive, and we're not going to initialize it with any value. So what value does it have? Let's try it out. I'm going to go here inside this statement and change type of. I'm going to reference here isActive. And what we're getting back here is undefined. So undefined is its own data type and simply represents something that isn't defined. We don't know. It is not a string, it's not a number, it's not anything else, it's simply undefined. We have created a new jar, but we haven't put anything inside there. So this is the representation of undefined. But it's important to understand this concept of undefined because we're going to encounter it a lot, as you will later see. Now, in this case, we have a lot of properties here that kind of belong to the same person, right? So we have a variable name, we have a variable age, we also have a variable isAdult. But it's obvious that this data actually belongs to a person. Now, in this case, if we want to make things more clear that, hey, all these variables grouped together actually belong to a person, we can use another data type, which is called an object. So let me show you how that works. And it's quite easy. So what we're going to do here is we're going to define a new variable to hold this object. I'm going to call the variable person. And in order to define an object, all we have to do here is use these braces. We'll have one brace in the beginning and one brace at the end. And I'm here between the braces. I'm going to hit one time enter and add a semicolon at the end. All right. So now we have here an object, but this object doesn't have any properties. So what we're going to do here is going to move these variables that we have here, and we're going to put them inside here. Now you'll notice as soon as we do this, everything will turn in red because this is not valid code. Now what we're going to do, first of all, is remove all the let definitions in the beginning. We don't need that anymore. Now after this, what we're going to do is we're going to replace the equal sign with a semicolon, and we're going to also remove the space before the equal sign. And last but not least, we're going to replace this semicolon with a comma, except for the last semicolon, which we'll simply remove. This looks very similar to JSON, but it is not JSON. It's super important to understand the distinction between a JavaScript object and a representation of a JavaScript object in JSON. While there are some similarities, this is not JSON, it is simply a JavaScript object. You don't have to trust me that this is a JavaScript object. Let's go ahead and take a look at the type of this thing to see what it is. And we're going to get back here, object. All right, so what can we do with this object? Well, for example, we can simply use here console log, and we can log the contents of this object so that we know what's inside this object. Maybe we don't know. So we'll be able to see here that if we expand this, that we have here multiple properties, name, age is adult, and so on. Now, quite often, we don't need the entire object at once. Maybe we only need the name for whatever reason. We want to print a message like hello, then the person name, right? So in that case, to only access one property, we're going to use what is known as a dot notation. So after person, we're going to write here dot. And you'll see here already there is a bit of autocompletion that kicks in. This is because this object has been defined here right inside the window. So let's select from the list name. And if we run this code once again, we're going to see here that the name is Jake. Perfect. So this is how we can access a property. Now, let's say, for example, for some reason, when we have created this object, we didn't have some information. We want to add some information later on. How can we do that? Well, we can simply use here person, and we can specify a new property. Let's say, for example, we want to add a property which is called email. So we can write person.email, and we're going to initialize here this property with a new value. So I'm going to write here something like jake@example.com. So if we log the entire object with console log, what we're going to see here in the list of all the properties is also the property email. And just as well, if we need to access it, we can use the dot notation. Let's say, for example, that we want to have here email with a dash between E and M. So written like this. Now, as soon as we write something like this, you'll notice here something turns into red. And here at the end, there's also this indication that there's something wrong with the code. So what's wrong with this code? Well, essentially, when we use here a minus sign, JavaScript will think that we're trying to access here person.e minus a variable which is called mail. And we're going to try to initialize this to a variable. Doesn't make a lot of sense, right? Now, in this case, if we're trying to do something like this, we need to use a separate notation. There's a special notation whenever we have some characters that, let's say, are a bit special and break our syntax that we have here in JavaScript. And for that, we're going to remove this dot, and between square brackets, we're going to put here email. So the idea here is that in order to make this a string, we also need to put it between quotes, because otherwise JavaScript will still think that E is a variable and mail is another variable, and it's going to try to subtract them. So even if the code now looks valid, if we're trying to run this, what we're going to get back here is that E is not defined, right? So that's also not good. So let's put everything between quotes. And now, what do we see? we have here this property email exactly as we wanted it. And it has right now the value that we need. The same thing goes when we're trying to access this property. So if you want to go here and write person dot, you'll notice here in the list, email doesn't appear. So if you're going to write here email like this, well, this is not going to give an error itself. But again, this is going to be like a math operation where JavaScript will think we're going to get a property e from person and subtract mail. So we're going to get this time the error that mail is not defined. Now you're probably wondering, why is person.e defined? Well, that's not defined, but that's not going to throw an error. So let me show you. Whenever we're writing a property on an object that doesn't exist, like person.e, this is a property that doesn't exist. This object does not have this property. What we're going to get back is our old friend undefined. So JavaScript not going to say, oh my God, this is an error, you cannot continue. Just going to say, this is a property that is not defined. Maybe you forgot to define it or something, but it is undefined. Doesn't throw an error. This is sometimes a bit confusing because maybe you are writing here a property like is adult, let's say is adult, and you forgot to put a capital A there. You're looking at this and say, oh, why doesn't this property work? It's right here in the object. It should work. I've written it exactly the same. Oh, well, almost exactly the same. Well, that's the problem. If you're not writing things exactly as they are inside the object, you're going to get this undefined. Okay, we're jumping into too many things at once, but let's go back to how do we get to this property? So we know that this notation with dot doesn't work. So we'll have to use this other notation with square brackets. So again, when we're setting a property, or when we're trying to retrieve a property that has some special characters that break our code, then we have to use this square bracket notation. We're not going to use it a lot, but you'll have to remember it because from time to time, we're going to need it. So this is essentially more or less what we need to know about objects here. Let's move this property to the object itself. So in this case, we're still going to use this notation. So we have to put this between quotes, single or double, doesn't matter. And we can put the value here. Then we have everything in one place. So this is our person. It looks much better. At other times, we may need a collection or a list of things. Things that are, kind of like similar to one another. And for that, we can use an array. An array is a data structure that can store a collection of elements, each identified by an index. Okay, sounds a bit confusing. Let me show you an example. So let's say, for example, we want to store here a list of hobbies. So I'm going to define here a new variable, which is called hobbies. And this time to initialize this array, we're going to open up a square bracket and we're going to close one. Now, at this point, we have here an empty array. So let me use here the Postman console. And we're going to write here hobbies. So we can take a look at this thing. So we're going to see here, this is an empty array. Some people think that this is some error or something like that. No, it begins and ends and there's nothing inside. Okay, so let's add something inside so that we can make this a bit useful. So let's say, what do we have for hobbies? Not a lot of people do it nowadays, but let's say reading, that would be one hobby, right? So if we run this once again, we'll see here one. So we have one element here and this is reading. Perfect. What else do we have? Maybe traveling and gardening and cooking. You can understand how these are related to one another, right? So they're all hobbies. So it kind of like makes sense to put them in a list. Otherwise, we would have something like hobby 1, hobby 2, hobby 3, and so on. When we don't know in advance like how many hobbies we have. Maybe we have none. Maybe we have 10. Maybe we have only 2. So this array structure allows us to be a bit flexible with how we store this information. Let's take a look again what we have here. So we're going to see here, okay, we have 4 hobbies. Perfect. Let's say, for example, we're only interested in the second hobby. How can we do that? Well, in order to access only one element of the array, we'll use, again, this square bracket notation. And this time we're going to specify the index. So it means the number of the element in the array. So each item is identified by an index. So we're going to write here, this is the first element, this is the second element. So we're going to write here 2. And let's see what we're getting back. And we're getting back gardening. This is kind of confusing, right? So let's remove this and go back to square one to understand what's going on here. Now, indeed, we have 4 elements here in the array. But if we expand this array, what we're going to see here is the index, actually. Now, remember that in computer science, we always count from 0. Arrays in JavaScript are 0 indexed, meaning that the first element is at index 0. The second element is at index 1, and so on. So if we want to get the second element, we actually have to write there 1, because you'll see here, traveling has index 1. No problem, a small hiccup. So we're trying to get the second element, we're providing index 1, and we're going to get to this array. Now, again, we have the situation that we have a person, which is an object, and we have this array separately, which is again a bit confusing. But we also have the possibility of actually putting hobbies inside the object. So all we need to do is define here a property. So I'm going to add here a comma so that we can add something new to this object, column. And now we're going to simply paste here the array. So let's take a look again at the person. And now we have here a more complex data structure. We have an object that also contains an array. So let's take a look at this. What do we have here? We have name, age, adult, and we have hobbies. We can still explore these hobbies and take a look at them. Now, how can we get to, let's say, the third hobby, right? So we cannot write here hobbies anymore because hobbies is no longer a variable. We have to go through person. We have person.hobbies. And if we're trying to get the third hobby, then we'll have to specify index 2. So this is how we can still access this information from the array, but using the object which contains now this array. Now there's one last thing about arrays. So if we're trying to do here like type of person.hobbies, we should get back array, right? When we're getting object. That's again confusing, right? Why are we getting object? Is it because this array is now inside an object? No, it has absolutely nothing to do with it. Actually, this is because arrays are objects. They are a more specialized form of object. However, we kind of like tend to work with them separately and consider them like separate things from objects because they have like these particularities that we need to learn about. And when we're interacting with them, they're super important. But at a technical level in JavaScript, they're also objects. This is why when we're trying to get the type of an array, we're going to get back object. In this lesson, we'll be exploring JavaScript functions, which is a fundamental concept in programming. A function is essentially a block of code designed to perform a specific task, which can be called whenever needed. This allows us to organize and reuse our code efficiently. So let's go ahead and define a simple function. To define a function, we need to write the function keyword, followed by the name of the function. For example, let's say we want to create a function that greets us, right? So we're going to give the name greet to this function. And then to make it a function, we're going to add here this parenthesis. And after this, we're going to start here actually a code block, which we have learned about a bit previously, and we're going to get to it a bit later. So this is the code block. This is where we can write some code, and this will be encapsulated. So essentially, these are like gates. They ensure that whatever happens in this function is isolated from the rest of the things. So for example, we can write here something like console log and display a message like hello from Postman. Okay, so let's put this back here where it belongs near the function. I just want to point out that this is actually a code block. Perfect. So now we have this inside the function. Our function name is greet. Well, let's run this again. And if we're taking a look at the console, nothing. Like nothing. Where is this console log statement? What has happened with it? Well, here's the thing. Just because we have defined a function doesn't mean that that function is being executed immediately, right? So initially, nothing happens. If we decide that we want to call a function and reuse some functionality that we have in that function, we need to invoke it or call it. So in order to call that function, what we need to do is to specify the name of the function, which in our case is greet. And not only that, we also need the parentheses at the end. This is what actually calls the function. And we can also add a semicolon there. So let's go ahead and run this code. And then we will see here, hello from Postman. So with this code here, we are referencing this function here named greet. And with a parenthesis, we are executing that function. Without a parenthesis, this would still be valid JavaScript code, but we wouldn't be calling the function. So we'll see here, there's no output that's being generated. Now our function is kind of like silly. It doesn't really do a lot. Let's make it useful. Let's make it greet us. How can we provide some information from the outside and make this useful? Well, in order to do that, a function can also take inputs in the form of arguments, which are values passed to the function when it is called. So essentially, when we're calling this function, we can say something like, we want to provide our name. So let's say I want to provide here val. And I want to say here something like, hello from Postman, val. So I want this name to be printed there in the console. Now, in order to do that, we also need to change something about our function. So here in the definition, between this parenthesis, we're going to define here a parameter. So we're going to call this parameter name. And then in the console log, we can also reference that. So we can say here, hello from Postman, comma, space, and then with a plus sign, we can use here name. So let's go ahead and run this once again. And we're going to see here, hello from Postman, val. Just as well, we can greet multiple people. For example, we can greet Jake, we can greet Jamie, and anyone else who would like to greet. So let's go ahead and run this. So we have reused the same function, but by providing a different argument, we have also changed a bit what the function does. Of course, this is a super simple example, but you kind of understand the idea. Now, I wanted to talk a bit about name here. Like, what's name? Like, what's name? Is it a variable? Is it, where has this been defined, or how does it work? If you try, for example, inside here to get something like console.log name, it's not going to work. You're going to get an error. Name is not defined. But if you're trying it inside here, obviously, this is going to work. Name here is like a variable. And this is why it's important to remember the discussion that we had about code blocks. This is a code block. And this function, what it does is essentially saying, here, this is a variable called name, and we're going to initialize it with whatever value is being provided here. I'm going to say here, like name equals val, right? Now, of course, this is not actually happening in terms of the syntax that is being used, but it's almost the same thing. So for every time we are passing a different argument here, this value will change. But it almost works the same as when defining a variable. But this is the work that JavaScript does for us by using this syntax, by the way we have defined this function. So it happens automatically. But the idea is name here is only available inside the function. It's not available anywhere else. Okay, so now we have this useful function. That's cool. But sometimes, we have, let's say, for example, we have developed a super secret algorithm that adds two numbers, right? So let's put that in a function. We're going to give it the name add. And this amazing function will add two numbers, like let's call them A and B, right? This will be parameters that we will have here in the function because, to add two numbers, we need to know those two numbers. So this is how we can take input essentially when we're starting this function. So what are we doing with these two numbers? Let's define a new variable. We're going to call it sum. And we can add A plus B. All right. So then we can use console.log and we can print out sum. And you already know the drill. In order to call this, we'll have to provide here two numbers. So let's add 1 and 2. And we're going to run it. And what we're going to see here is 3 in the console. Perfect. Okay, this kind of works. But let's see if there's anything else we could do here. So for example, let's define two variables. Let's call them number 1 and gonna provide here one number. Don't need a space here actually. This will be number 2 with a different value. So let's say we want to display here a nice message like using console log, the result of adding, and we're going to specify here number 1 with, going to add the next number, number 2 is, and let's say we want to call this function add here so that we can display everything in the message. I'm going to use here the plus sign again. We can reference variables as well. So what we're going to do, we're going to add number 1 and number 2. Perfect. We still have here a syntax error, so we need to make sure that when we're combining different strings that we are using the plus sign. So the result of adding number 1 with number 2 is we're going to call this function. So we can call the function even from within console log. So let's run this once again. And what we're going to get here is something interesting, right? So we have here 58, and this is coming from here. We have console log. So the function works. It adds these two numbers and displays them. But then when we're trying to use it here, it says the result of adding 24 with 34 is undefined. Again, this annoying undefined thing, which is driving us crazy. Why is this happening? Why is the function adding the numbers, but when we're trying to use it, it disappears? Here's the thing. Just because we use console log in a function, it does not mean that the function returns a value. Console log is just useful for debugging your code or understanding what the code is doing. But in this situation, we actually want this function to give us back sum. Just because we have used console log, it doesn't give us sum because we can use 10 console log statements, right? So it wouldn't make sense to just randomly pick one of them or just take the last one and send that over. What we need to do is to add a return statement. So a return statement is used to specify the value that the function should return after it is done whatever the function is supposed to do. In this case, because we haven't specified a return value, well, you guess it, by default, a function will return undefined because we haven't really defined what we want to return. So if we haven't defined what we want to return, we're going to get back undefined. So in order to not return undefined, we're going to use here the return keyword. And we're going to say, but what do we want to return? How about returning sum? So when we're running this once again, we're keeping here our console log statement, which is useful for debugging and understand what the function is doing. But then we also get here the value, which is being displayed through the console log statement. So this is why it is important to have this return statement in functions. Just because you have added console log, does that mean that the function actually returns what you see in the console? We can also define a function inside an object. So let me show you how this works. We have here an object with some properties, and let's say we want to add this function to the object so that we do something in relation to the object. So in order to do that, things are relatively simple. We're going to copy the code that I have here. I'm going to go here inside the object, and I'm going to simply paste the code. Obviously, this syntax is not correct, but we are actually not so far off. There are a few things we need to change. Now you can notice here that the object always has something like a property and then a value. Now we need to keep the same structures. We're going to start here with a property, which is greet, the name of the function. I'm going to add it here. And then with column, this is essentially going to replace here any equal sign or something like that. We're going to say, okay, we have here greet, and greet is a function that takes name as an argument and does something with it. So if we're trying to access this function, all we have to do is write here person.greet. And in order to call it, we need to use parentheses, and greet also takes an argument. So we're going to write here Jamie. So let's see how this works. I'm going to see here hello from Postman, Jamie. Let's add here another space so that it looks well. And we're going to get this to work. When a function is defined inside an object, we call it a method. While they look similar, they're not really the same. Functions can be defined and called independently without being associated with any particular object. On the other hand, a method is a function that belongs to an object and is designed to perform specific tasks that is related to that object. So for example, let's say we want to also display the first name, right? So we are getting some argument from the outside, but how about accessing some information that is inside here? We can write here maybe a special message like my name is, and then we're going to take the first name. So hello from Postman, Jamie, and then we're going to continue the message. Dot, so we're ending the first sentence. My name is, space, and then with a plus sign, we'll be able to use here first name. So let's paste it inside here. Gonna get this to run, and we're gonna get here an error. First name is not defined. Okay, that's a bit of a problem. We could use here person.firstName because of obviously first name is a variable, it doesn't exist. So in order to get this to work, then we're gonna use here person.firstName. So let's run it once again, and we're gonna see here my name is Jake. Now this has a minor disadvantage. If we for some reason decide to rename this in person2, from the outside would know that, hey, this is person2, so we're gonna use person2.greet. But here on the inside, maybe we forget to change that. So again, we're gonna get an error here, person is undefined. That's a bit unfortunate. And exactly for this reason, if we're trying to reference an internal property of the object, we can use a special keyword. And this keyword is this. So we can replace person or person2 or any other person with this. So if we run this once again, we're going to see here, my name is Jake. If we're changing this back to person, it's still going to work. So it is an ideal situation to use this if we're trying to access some internal data in a method that we have defined here. Now, methods and functions, they indeed look similar and they kind of like work similarly, but it's important to understand what is a method and what is a function, even if they are kind of similar. For example, when we're using here console.log, right? Oh, well, console is an object. We can write here something like type of console. Let's see what's console. Console is an object, which means that console.log is then a function. And we're going to see here, it's a function. But because it is like technically in JavaScript, it is a function, but because it belongs to an object, we're still going to call it a method, right? So we don't have this data type, which is called method and function. But when we refer to an object that has a function, we're going to call that a method. And when that function is standalone, we're going to call it a function. Anyway, console.log, when we're calling log here, this is actually the method log on the object console. So now you understand exactly what console log is. This is something that's provided by Postman and it has been defined somewhere else. We can just simply use it. So this is an ideal example for what it means to reuse something. We don't really know or care exactly how this information is being displayed here, why everything is on a new line, why everything is nicely formatted. This is something that it's a concern of this method. It's being put together in this method so that we can conveniently use it whenever we need it. Callback functions are an essential concept in JavaScript programming, allowing us to write more efficient and flexible code. Postman uses callback functions, and it is important to understand what they are. So let's begin with a few basics. The first concept I want you to get familiar with is that we can store a function in a variable. So what we're going to do here is I'm going to define here a variable, let's call it say hello, and I'm going to initialize it with a function. So we can simply write here function. And what is our function? This will be our function code. And we can have here a simple console.log statement which says hello. Super simple. So which means in this case that what's the name of this function? This function doesn't have a name anymore. It's just stored in a variable. This is called in JavaScript an anonymous function. When a function doesn't have a name, it is anonymous. It doesn't have a name. So in this case, if we want to actually run this function, if we want to run the code that's in this function, the only way to do that is by using the variable where this is stored. So we're going to use here say hello. This is the variable. And remember, in order to invoke the function, we need to use parentheses. We're going to add here this parentheses, and this is what makes the call to the function. So let's run this, and we're going to get here back hello. Okay, so we can store functions in a variable. Good, big deal. Why do we need this? Well, we're starting to get there. The next concept I want you to get familiar with is that functions can also be passed as arguments to another function. Okay, so how does that work? Well, let's say we have this regular function which is called, do something, right? So this is a regular function. And as you know, a function can take here some arguments. So we can provide some inputs that we want to give to the function. Now, in the past, we have provided like two numbers, A and B, which we have added, or we have provided a name so that we can say, hello, Jamie. But we can also provide here a function. So I'm going to write here some function because we don't know which function this will be. And here inside the code, we now have this function and we can decide to run it. So let's write here a statement like console log before running the function. And we're going to have another console log statement after running the function. And here in between, we have here some function, which is a reference to some function that we're going to get. And we want to call that function. So in order to call that function, we're going to use here, you guessed it, parentheses. So now we are calling a function that we are retrieving here as a parameter. So how can we do this? Well, the next step would be to call do something, right? Because at this point, do something isn't being called anywhere. And we can reference say hello. So we are passing say hello as an argument to this function, which is called do something. Do something will retrieve it here, will run console log, then it will invoke some function. And it doesn't matter if the name is not say hello. This is being passed here as a value, and it will call here this function that we have here. So let's run it and see if it works as intended. So what we see here is that we have before running the function, this is the first statement. Then we have hello, which is coming from here. And then we are after running the function. Okay, you're probably thinking, oh, geez, that's a really complicated way of calling this function. I mean, why in the world would you need something like this? And again, we're getting there. And I do appreciate your patience with this. It's super important that you get this. So let's take it step by step. So to recap, we can put a function in a variable. We can pass a function to another function and invoke that function here. Maybe there's some condition here upon which we decide to invoke that function. Doesn't really matter. But these are like the first ideas that we need to get familiar with. Now, what if we don't want to define this variable say hello, right? In the past, when we use something like saying hello, we have just written there as a string, for example, Jamie. Why can we not write the function directly here inside this function call? Well, actually, instead of using here say hello, we can simply copy the contents of this variable. I'm going to remove this altogether, and I'm going to paste it here. Looks a bit crazy, but let's see if it still works. So it works absolutely the same. Before running the function, then we are running the function, and then after running the function. So now, again, we have this anonymous function, which we only need maybe one time, and we have passed it here when calling this do something function. And what I want you to get is that this function, this code, is not being called here. This console log statement is not called here at line 8. it's actually being called here. If we, for some reason, decide to comment this, and we're trying it once again, we're going to see here the hello statement has disappeared. So this is what is running our function. This syntax is a bit confusing in the beginning. This is why I try to take you step by step so that you understand the syntax, the way we write these things. In the end, if we write here a function, if we write here a string Jake, if we provide one number or even multiple numbers, it's the same idea. We are calling a function which is called do something, and we are providing one argument. So the argument starts here and ends here, and then we're closing the function call. So the function call is this one. Let me remove it once. This is how we're calling the function. And here, between these parentheses, we are passing one argument. Just as well, we could be passing two arguments or multiple arguments. Same idea. Again, you're wondering, why is this useful? When I'm going to need something like this? And it's obviously not easier to read than before. Well, let me explain a bit why we went through this effort of trying to understand these callback functions. The reason is that Postman uses them. So here in Postman, if we're trying to write a test, and I'm going to expand here the snippets once again, I'm going to go here to the status 200 test and add it here again. Now what you're noticing here is maybe something familiar, right? So what do we have here? Well, we have pm.test. Well, pm, this looks like an object. And test looks like a method, right? It's starting to accept some arguments. So what are the arguments that this is accepting? Well, let me make it easier for you to understand. So we're going to define here a variable which we're going to call name of the test. And the name of this test will be this one. So this is the name of the test. And let's define another variable which we're going to call maybe assertions. And this will be a function. And we can reference it here. This is what a Postman test consists of. It uses the PM object and then the test method, which has two arguments. It takes the name of the test and a callback function containing assertions. So assertions in this case is a function. What is sometimes difficult for beginners to understand is this syntax, because it's not clear, well, where does the method call start and where does it end, right? So this is why I try to break this down into smaller steps so that you can understand where is the name of the function. This is the name of the function, right? So I'm going to put it back together again. So name of the test, this is the name of the test. We're providing it directly without using a variable. Much easier and much faster to write. And then as a callback function, we're going to provide here the assertions that we're going to use. And we're doing it like this. This is how we end up with this particular syntax when we are writing Postman tests. Now, I hope that learning about these callback functions hasn't been a waste of your time, because now you understand what is a Postman test and how it is composed and which are the arguments that we need to pass in order to construct the test. Of course, we'll go further into this test, but this is why we have learned about this. If you're not familiar with JSON, this lesson will provide a quick introduction to it. If you already know what JSON is, feel free to skip ahead. So what is JSON and why do we need it? When working with most APIs to send and retrieve data, we need to use the JSON format. So essentially we use JSON to send requests from one machine to the other. In this case, Postman is running on our machine and we need to send a message to the API server, for example, to order a cappuccino, right? And then in order to essentially place this order, for example, we cannot simply say, like we would say to a human, yes, I would like a cup of cappuccino or something like that. We need to format our message in a way that the computer can understand it. Let's take a look at an example so that you can better understand what JSON is. So the JSON format is pretty straightforward. JSON has a simple key value format. It is like saying first name equals Jamie. So we are assigning to first name the value Jamie. But instead of using an equal sign, we actually use a column. And we put both the key and the value between double quotes. And then we're still not ready, but we're going to surround everything with curly braces. This essentially creates an object with one property. If we need to add an additional property, then all we need to do is create a new line and separate those two lines with a comma. You can notice that in this case, 22 is not between quotes. 22 is a number and it doesn't require any quotes, otherwise it will become a string. The same goes for booleans. Booleans, true or false, also don't need quotes. The beauty of JSON is that it is both readable by humans as well as by computers. You can read JSON without essentially knowing a lot about the JSON format itself. A confusing part about JSON is when you encounter square brackets. Square brackets allow you to specify a list. In this case, we have a list of hobbies, and you will notice that there are multiple values between those square brackets. Inside the square brackets, we define a list of things. It can be any type of values like a string, a number, a boolean, or anything else, even an object. So let's do a quick recap. First of all, we can see that we have keys and values. First name, age, is married, and hobbies are all keys. Jamie, 22, false, and then the list of hobbies like Netflix and mountain biking, they are values. Jamie is a string because it is between double quotes. When we want to add another property to this object, we must add that comma. Otherwise, our JSON will become invalid and the other party will not be able to understand this message. So commas at the end of the line, except for the last line, are super important. 22 in this case is a number. False is a boolean, and Netflix and mountain biking are an array. Notice the square brackets and individual values separated by a comma. Finally, you will see that the object is enclosed by curly braces, one at the beginning and one at the end. So in a nutshell, this is the JSON format. In this lesson, we will dive into the world of JSON and understand how to parse JSON in Postman and how to use console log to read a specific value from the API response. We are done now with learning the JavaScript basics, so let's transform our Postman interface back to our original state. So first of all, we can enable this single pane view by clicking here on the bottom, single pane view. This will put again the response here in the lower part. And initially, we can simply go ahead and close the console. Apart from this, we can also enable the list of collections that we have by enabling here the sidebar. And we should be back where we started. Let's go ahead and close the get API status request and expand the product folder and go to the get single product. What we have inside here is a product ID. So if we go ahead and try to retrieve this, we're going to get a single product. Perfect. Now let's say we want to work with some information that we're getting back from the API. How can we do this? Well, what we see here is JSON. This is the representation of a JavaScript object. JSON stands for JavaScript Object Notation. It looks pretty similar to how we have defined an object in JavaScript, but there are still a few differences. Now, the thing is, we cannot work with what we have here. If this is like a pretty view that Postman offers us, but actually the data that we're getting back is this one. This here, what you see here, is simply a string. And we cannot do anything with it. We cannot read a property. We cannot access any information or something like that. So for that reason, we need to transform this string that we see here into an object that we can use. Now, this transformation from a string into a JavaScript object is called parsing. And we need to do this from a Postman script. Now, the question is, where can we parse this? Should we use the request script or should we use the test? Well, the thing is, this information is only available after we have sent the request and after we have retrieved a response from the API. This is the response from the API. And this information is only available here in the test. In the pre-request script, that's a bit too early. So we need to go here inside the test and do something with this. Now I'm going to enable here the pretty view again so that we can get a nice view of the information that we're trying to work with. Now in Postman, in order to interact with this, there are already some predefined methods that we can use. So we're going to use the PM object. And on the PM object, we have here actually another object which is called the response. So we'll see it's available here on the list. I'm going to select here response. And there is a method which is called JSON. So when we are calling this method JSON, it actually gets the response body and transforms it in a JavaScript object. So this is what this method is supposed to do. This method will return a value. It's not going to print to the console or something like that. So if you want to use this for later on, what we actually need to do is to store it in a Postman variable. So I'm going to go ahead and define a Postman variable, which we can call response or response body as you prefer. I'm going to go ahead and write here const response. But this is actually storing the response body. Just keep that in mind. All right, so now we have the response. So we can go ahead and use console.log and take a look at this response to see what we have here. Let's open the Postman console, run this request once again. And what we're going to get here is this object which has different properties. So for example, if we're trying to maybe get the property ID, all we have to write is response.id. Now what you need to pay attention here is that we no longer have this auto-completion. In this case, Postman doesn't have the information what kind of an object we have parsed here, what kind of a data structure we have, what kind of properties are available, and so on. So for this, when you're typing the code, you're not going to get the auto-completion. For that reason, it's always super important that you pay attention to what you're typing. So I'm going to write here response.id. I'm going to get here the ID. But if I'm writing here ID with a capital I, I'm going to get back undefined. So for that reason, what I always recommend, especially when you're getting started, simply copy paste the information. If you're trying to get here, the property is available, just write response.isAvailable and copy that from the body. So you see here true. So isAvailable is true and it's the exact same value from here. If you're trying to get, for example, the product description, you need to remember that this is a bit trickier, right? So if you write here something like response.product minus description, this again will fail. You're going to get essentially an error saying that description is not defined. The response.product will be undefined and the description variable is also not defined. So in order to do that, we'll have to use the other notation that we have learned about it in the past and put this as a string between these quotes and then use this square bracket notation. So this will help us get the information that we are looking for. So in a nutshell, this is how we can parse JSON into a JavaScript object. And when we have a JavaScript object, everything that we know about JavaScript objects still applies. The way we work with these objects, the way we read properties, the way we change things, and so on. Previously, we have seen how convenient it is to set a Postman variable and then have a bunch of requests magically work just because we have set the right value. This is the power of using Postman variables. As you have seen when we have tested our collection, there are a few things that we still need to copy around. So for example, we went here as all products and we have found a product. And then what we need to do is copy a value and then set it in the upcoming request. Well, while there's still a bit of work to do this, we can use Postman variables and later on, we're going to even improve this process. So let me show you what I mean by that. So in this case, we have here this value, product ID. So let's say we want to order this product, but first we want to check if this product exists. So we're going to send this request and check, oh, okay, this is a product that exists and it's actually a product that is available. Great. And then we need to copy the same value and go into the orders, create a new order, and then put that value here, for example. Now, let's say for some reason we decide we no longer want to order this product, we want to order a different product. Then again, we'd have to search for a product, check that that product exists and that it is maybe the right product that we want to order, and also update the create a new order request. We can slightly optimize this process by using Postman variables. So what I'm going to do here in the get single product request, I'm going to replace this hard-coded value here, and I'm going to set a Postman variable. So you can see here, if I select this text, I'm going to get this context menu here set as variable. Now, if you don't see this, that's absolutely fine. You can simply go ahead and manually create that variable. I'm going to show you in a second how to do that as well. But if you see this, simply click on set as variable. And what we're going to do here, we're going to set as a new variable. And all we have to do is provide a variable name. And I'm not going to be very creative here. I'm going to just write product ID. And in terms of the scope, I'm going to select the collection scope. So essentially, we're going to save this as a collection variable. So let's go ahead, click here, set variable. And now this is a variable. If we hover over this, we're going to see its value. If you didn't see this context menu, which allows you to add a variable from here, no problem. We can hover over the collection name until this ellipsis shows up. Click on edit. And from the variables tab, you will be able here to simply go ahead and add a variable manually from here. Of course, later on, if you want to change this variable that we have created earlier, you can simply change its value from here. Remember, if you want this value to take effect in Postman, you always need to change the current value because this is the one that's being used by Postman. All right, so we have it now in a single place here. So what to do next? Well, we wanted to reference it here when we're creating a new order. So all we have to do is remove this value. And then I'm going to write here 2 braces. And all I have to do is start typing product ID. You're going to see here appearing in the list of suggestions. And let's go ahead and submit this request. So what we're getting back here are the products that we have ordered. And you'll see here, this is the product that we have then referenced through this Postman collection variable. So this saves us a bit of time in terms of ensuring that a product that we have retrieved earlier is also available, and we can manage all this through a Postman variable. So let's take a look at an example where we're going to change this to something else. So let's copy this other ID that we have here, and I'm going to go inside the collection and simply change the variable here. So this time when we're getting a single product, we're not going to make any changes to the request, just submit it. You will see here this ID has changed. And just as well in the create new order, we're going to submit this again, and we're going to see here this ID has changed as well. We can do also something similar here with get all orders. So from the list of all the orders available, we can simply take a look and getting an existing order ID. In this case, we're going to have to hard code one of these values. So let's copy one of these. I'm going to go back into the collection, and I'm going to define here another variable, which I'm going to call order ID. And I'm going to simply paste the value here. Make sure to save the collection, otherwise the variable will not be saved. And then when I'm trying to get an order by ID, instead of having this hard-coded value, can I simply go ahead and select here from the list of variables that are available, order ID. If I hover over it, I'm going to see what is the current value that will be used for this request. We can go ahead and submit this request, and then we're going to see we're getting back status 200 OK. We're going to get information about this order. Maybe it doesn't seem so useful at this point, but understanding that you can use Postman variables to store this kind of data that are coming from one request and use it in other requests as well is super important. And we're going to work towards eliminating this manual process of copy-pasting data. In this lesson, we're going to take a look at how we can set Postman variables directly from a script. Now, just as a recap, we have learned about Postman variables, and we have learned about JavaScript variables. JavaScript variables are not the same as Postman variables. While essentially a variable is a way to store something, they work a bit differently. JavaScript variables are scoped only to the script where they are defined, and no variables are persisted, meaning we set a variable in a script, and then if we remove it, we're not going to be able to retrieve it once again. Well, this is why we also have Postman variables. Postman variables allow us to store some information between requests and even later on if we need so. So for example, we can store settings and persisting data on the long term, such as the base URL or the API key that we have previously generated, or any other details that we need. So we have this information as Postman collection variables. But Postman variables are also useful for passing data between requests. So sometimes we retrieve some information in one request, but we also need it in another request. For example, here with the orders, we're creating a new order, but maybe we also want to get the same order later on and check if that order has been properly created. That order ID is something that changes all the time. So yes, we can use a Postman variable, but we'll have to constantly change this. So let's take a look at a way on how we can improve this process. The concept I want you to get familiar with is that we can set Postman variables from scripts. So I'm going to go ahead and run this request once again. So let's say we have this value here, which is the ID of the order we have just created. So we can go here inside the test. And here inside the test, we can write something like pm.collectionVariables.set. And we can either update or create a variable if it doesn't exist. In our case, if we're looking here at the getAnOrderById request, we're going to see here we already have here this variable order ID. So let's try and update that. I'm going to use here the name of the variable, which is order ID. And then we can also set here a value. So we're going to take this value that we have here in the body. Let's run this. So you'll see here, this is something with FB8T and so on. We open this other request and we are hovering over order ID. We'll see here that the current value has been updated. So we have updated this variable from a script. Now, okay, the problem with this approach is that we now have another ID here. So if we're always trying to get the latest ID and then get an order by that ID, this approach is still not super useful. Now, in that case, there's still something else we can do. We are gonna go ahead and actually read this information from here because we now know how to write some scripts and we can level up our automation game essentially by employing this nice trick. So what we'll do next is we're gonna define a variable which we're gonna call response, and we're gonna store inside the result of parsing the response body. So for that, we're going to use pm.response.json. We're going to call it as a method. So now response holds this information. And whenever we're trying to do something, it's always a good idea just use console.log. And what we're trying to do, we have here response. Let's open the Postman console. And we can see here, okay, we have access to the response. So it looks good. What are we trying to get? We're trying to get this ID. So let's write here response.id. Can we see this information here in the Postman console? Yes, we can. Here it is. This is the latest ID. And you can see it's the same as we see in the response body. All right, perfect. We're making amazing progress. How can we update the Postman variable with this information that is in the body? Well, all we have to do is remove this hard-coded value that we have here and use response.id. So let's see again. We're parsing the response body. We're updating a Postman variable called order ID. Let's run this. So now we have this value. We're going to copy it just to cross-reference it. And now let's run this request. You can see that the Postman variable has been updated. Let's click on send. And we can search here the body. I'm going to click on this one, paste the value that we have copied. We're able to see that is the exact same ID. So what has happened here is that we no longer need to copy-paste data from the create an order request to the get an order by ID if we're trying to retrieve the latest order. So we can just run this once, go to the next request, and run it as well. This is the power of being able to know how to write these scripts and know how to use Postman variables to store information between the requests. We will conclude this unit with an easy assignment. If you have been following along, you already did most of the work. Now, all you need to do is to go back to the original workspace from where you have forked the collection. Inside here, you'll see this list of assignments that you need to complete by the end of the course. Completing all these assignments is necessary for you to get the Postman badge that certifies you have taken this course and have done the work. Let's begin with the first assignment. In order to complete the first assignment, what you need to do is fork this collection. So all you have to do is hover over this until this ellipsis shows up, and from the menu select Create a Fork. Make sure to fork this collection in the same workspace where you have also forked the collection containing the API. Each assignment contains instructions. So if you're not sure, all you have to do is click on the collection, and what you will see here is the documentation. Just in case the documentation doesn't show up, you can also access it from here. Since this is your first assignment, I will guide you through the steps you need to take. So we already did the first step, and that is to fork the collection. Now the next step is to actually read the instructions that we have here. So there are multiple tasks that you need to complete, and these are things that we already did in this unit. In a nutshell, you need to put here inside the API request folder some of the requests that we have worked on the original collection. So what you need to do, for example, for the first task is to take the get API status request, to duplicate it here, and then to simply drag it into the API request folder. Inside here, we want to make sure that we remove copy. So in the end, the name of the request should be exactly the same as here. Now you will do the same with all the requests as instructed by the documentation. So there are 3 requests that you need to add: the get API status, the get single product, and also get all orders. Once you have done so, you can jump to the next folder. And this is where you can check your solution. This folder contains the request as well as instructions on how you can verify your work. Essentially, it is a way for you to check that you did everything accordingly. This request also contains documentation, which are essentially step-by-step instructions on what you need to do. But let me give you a hand. Essentially, this request here will try to fetch your collection and will do some tests on it to make sure that you have written the code and did all the tasks that were required. So let's go ahead and run this request and see what is happening. Now, in this case, we're going to get an authentication error because we actually need an API key to be able to use this API. Just as well, we also need here the collection ID. This is an internal ID that a collection has. So let's start with that one. How can we get the internal collection ID? Well, all we have to do here is click on the assignment. And what you will see here is this I button here. If you click on it, you will get additional information about this collection, including the collection ID. So all you have to do is copy this collection ID, edit the collection, and go to the variables. You will see here that there are already 2 variables that have no values. So for the collection ID, we'll have to paste here the current value. The next thing that we need is still the API key. So if we try this request once again, it will still not work. So what we'll need to do is click here on our profile picture and select Settings. And this will take us to our Postman account. Next from the menu, we're going to select API keys. and we're going to generate a new API key. Let's name this API key Postman. I'm going to go ahead and copy this API key and go back to the workspace and the collection. Select the collection assignment 1, go to the variables, and in the current value, paste this API key and save it. Let's expand the assignment once again and go to the verify your work request. I'm going to go ahead and send this. So what we're getting back now is a status 200 OK. And if you take a look here at the test results, you will also see that some of the tests, you will see here an indication if the tasks that you've done are complete or not. Now, ideally, you would start with this once you're getting a status 200 OK, because this indicates this request is working in the sense that it can fetch your Postman collection. It's always important that when you're making changes that you're saving them, otherwise the test that you see here will continue to fail. So this is just a quick introduction on how you can approach this assignment, and this is also valid for the upcoming assignments as well. Your job is to ensure that everything here will get a pass sign, and you do that by closely following the instructions given here in the tasks. Always check that you are naming the request exactly as indicated and that you follow all the instructions. I wish you good luck with this one, and if you're encountering any issues, please use the Postman community forum for posting about the problem you're encountering and add there as many details as possible so that we can help you out. Welcome to the second level in our API test automation quest, where we flex our brain muscles and craft some tests that will put our API to the ultimate challenge. Aren't you tired of clicking through your Postman collection and squinting at each response to see if everything is working as expected? So far, we have inspected the status code and response body to determine if our API calls were successful. This is a very basic form of testing. We have manually tested if the API works. Doing it once is fun, but doing it multiple times, not so much. Well, my friends, buckle up, because in this unit, we're going to automate all this tedious work. We'll be diving into writing API tests using Postman. With Postman, we can write a tiny bit of code that automatically checks if all the criteria we deem relevant have been fulfilled. We'll be checking status codes, response headers, and response bodies. We'll even dive into JSON schemas. We're doing all this work now so that later we can kick back and relax while Postman does the heavy lifting for us. So no more manual checks or copy-pasting data between requests. It is time to level up your API game and embrace the power of automation. So without further ado, let's jump in and start writing some tests. In this lecture, we will discuss the structure of a test in Postman. So what do I mean by the structure of a test? Let's open up the status endpoint and start writing here a test. Now, a test in Postman needs to start with pm.test, and this method has two arguments. We need to specify the name of the test. We're going to call it like example for a moment. And we also need to specify a callback function. So we can write here function, and this will be our callback function. I'm going to hit here the enter key so that we have a bit more space. And this is the basic structure of this test. Now, at this point, this test doesn't do anything. This is like an empty shell. So we can go ahead and click on send. This test will show up here in the test results. You will see here the name example, but it doesn't do anything. In order to make this a test that will fail if needed, we need to write assertions. And we're gonna write these assertions exactly here in this callback function. This is why we need this entire structure. So how do we write assertions? Well, an assertion is essentially something that we expect. So with an assertion, we are gonna assert something. So for example, let's write pm pm.expect. And we're going to expect, for example, 1 to EQL, which comes from equal 1. So in this case, we're practically saying we expect 1 to equal 1. Of course, this is a very simple expectation, and all the data that we have is hard-coded. But let's take a look and understand how this works. So in this case, the test passes because 1 does equal 1. However, just as well, we could have here the expectation that 2 equals 1 or 3. Now in this case, this test will fail. So the first test with the status code will pass, but then our second test that we have will fail. We're going to get here this assertion error, and it's going to tell us, hey, look, 3 doesn't equal 1, and it's going to fail. A test in Postman can contain one or multiple assertions. As soon as one of these assertions fails, the entire test is considered failed. Once Postman detects a failure, it will stop the test and not execute the upcoming assertions if there are multiple of them. In this assertion, we also have a bit of a structure. What we expect here, this is what we will typically get from the response. So this is something that we don't know. This is why we need to make an expectation about it. And on the second part here to equal, this is the part that we know. For example, maybe we expect a product to be available, and then we would say something in regards to the product to be true, because available will be a Boolean. The point of this initial lesson is to get you familiar with the structure of having a test and having assertions inside that test. There's also something that you need to pay attention to. For example, if you write something like pm.expect 1 to equal 1 with a triple equal sign, this test will appear as it passes. However, if you write here 1 equals 3, this test will also pass. What you see here is actually an incomplete and incorrect way of writing an assertion. So to write an assertion in Postman, you have to use pm.expect, and you're specifying here something. Then you need to specify the expectation, the value that you think this initial part will equal. Just writing something like this is totally incomplete and will give the impression that everything is working fine when actually it isn't. So pay attention to how you're writing this test and make sure that you are following the structure that I've mentioned earlier. And this is using pm.expect, having something here, then to equal something else. Let's turn our attention back to this test, and in particular to this assertion. As you can notice, this assertion is not using pm.expect, it's using something else. Well, in Postman, there are a few expectations that we can write a bit differently, but probably most of the time, like 95% of the time, we're going to use pm.expect. Still, I want you to show you a different way on how we can write the exact same expectation, but using pm.expect. Now, in order to use pm.expect, which looks like this, pm.expect, we need here somehow the status code. We don't know from where we can get at. And then we need to write something like to equal when we expect it to equal to 100, right? So this would be, in a nutshell, the expectation. The missing part is this one here. Now, what we could do here is use console.log and use pm.response, because this is where the response is being stored in Postman. So let's take a look at what is happening here. Now, our test will fail because we have written here essentially undefined to equal to 100, and this will not work. But we have also logged here pm.response. So let's see what this thing is. Well, as you can see here, in essence, pm.response is an object that has some properties. So we have here a property status, and we have here a property code. Well, we could use property code. So let's write here pm.response.code. Run this once again. And we're going to see here the value 200. So what we want to do next is we want to make an assertion with this one. We're going to copy pm.response.code. This is what is coming from the response. This is essentially what we don't know. And then we're saying, well, we're expecting the code to equal 200. So let's go ahead and run it. It's working perfectly. If you're writing here status 2, so we're changing the URL to something that doesn't exist, this assertion will still fail. So this is just an alternative way of writing the same assertion, but this time using pm.expect. Welcome to the second assignment of this course. Your job is to write a status code test for every request that we have in this collection. Having at least a status code test is the most basic thing that we can do when we're doing API testing. So whenever we're testing an endpoint, the status code test is the first test that we're going to write. So this is why when we're starting API testing, we should ensure that every request has documented status code test, which indicates what is the expected status code for that particular endpoint. From the original workspace I have linked in the course notes, you need to fork the collection named assignment 2 and follow the instructions from there. Before we start doing something with the response body, it is best not to assume we get JSON back. Sometimes the API might misbehave and return something unexpected, like HTML. Let me show you. I'm going to go ahead and expand the products folder and take a look at the get single product, where we already inside the test have some code where we're parsing the response body and then we're trying to log a property. Now, typically, if we're getting back a JSON, this works without any issues. However, let's make a change to this. Instead of products here, I'm going to write here products 2. And I'm going to go ahead and submit this request. Now, what we're getting back here is a status 404 not found. And apart from this, we're getting back here HTML. This is essentially what's being used to display web pages. And this API is not perfect and in some situations does return back HTML without knowing that we're not really interested in HTML. Still, we need to be prepared for such situations. Apart from this, what I want you to notice is that here the test results appear in red. Now, even though we haven't written any tests, we're going to get this nasty error here telling us there was an error evaluating the test script and there's some problems here. When we're writing code in Postman, it is best to encapsulate this in a test. If an error occurs in a test, it's not going to propagate outside of the test. So essentially that callback function provides some protection around the code that we're writing. Let me show you what I mean. So we're going to write here a test where we want to assert that the response body is JSON. So I'm going to write pm.test. I'm going to write here response body is JSON. So this is the first argument. Then I'm going to write the callback function. And inside the callback function, let's move our test. So I know that currently this code is not properly working. Now let's send this once again. And this time, what we're going to get back is a test result. And we're going to get the information that this test here, which doesn't contain any assertions, but the code that is inside this test has actually failed. And we're getting here a JSON error, and it is practically the same error. But what's important here to notice is that this code doesn't prevent other code that we have inside our test from running. So any errors that appear will be limited to this callback function. Still, this is not a way of actually testing if the response body is JSON. So in order to test if the response body is JSON, we actually need to write an assertion. And this is, again, one of these special assertions that don't use pm.expect. In this case, we're going to write pm.response to be JSON. Super easy to read and also super easy to write. let's run this once again and see what is happening. And in this case, now the test is still failing. This is expected, but we're going to get here this assertion error. It's going to tell us expected response body to be a valid JSON, but got error unexpected token at something. Okay. And if this assertion here fails, this code here is no longer being executed. So when we're working with JSON and we expect to get back JSON from an API, it is not a bad idea to start with a test where we are checking that the response body is JSON. If the response body is not JSON, you shouldn't worry with further assertions because we're going to get some unexpected errors. Just testing if the status is 200 or checking that we're getting back JSON is not enough to really verify that an endpoint is working as expected. Sometimes we want to wish if a property from the response has an expected value. So how can we do that? Let's take a look at the response once again. And in this case, I'm just grabbing a product here. So it doesn't really matter which product it is, but I'm having here a bagel. So I would like to check that this property name is actually bagel. So let's go ahead and write a test, pm.test, and the name of the test will be product is bagel. And I'm going to also add here the callback function. Perfect. So in order to write these assertions, first of all, we need access to the response body. And as you have seen here, we already parsed the response once. So theoretically, we would be able to use it here as well. So we can use pm.expect. I'm going to write here response. And from the response, what are we trying to get? We're trying to get here the property name. I'm going to write here 2 equal, and we're going to hard code the value bagel. If you're using a different product, make sure to specify a different value. Let's go ahead and run this. And surprisingly, this test is failing, and we're getting here this reference error, response is not defined. But response is defined. How come it doesn't work here? Well, this is where understanding JavaScript basics are super important. Remember those code blocks? Well, when we are here inside a function, we are essentially inside a code block. So whatever we define here is not going to be available somewhere else. Still, if we put this outside, that's going to cause other problems because we're going to try to parse the response without knowing if it is actually a valid JSON. So what we could do in this case is simply define here response outside. So we're going to remove here const. And this time we're going to use let response because we're changing its value. We cannot define it with const. So we have here let outside in the global scope, which means we have access in our callback functions to this. So then we can use response.name. Let's give it another try. And we're going to say here, response body is JSON, product is bagel. This is passing without any issues. Just as well, we can take a look at another property. For example, let's say we want to check the price. So we're just going to go ahead and simply copy paste the same expectation that we had before. And you notice me, I'm using here copy paste. Always use copy paste when you're working with properties from the response body, because this ensures you're not making any mistakes. So response.price, well, what is the price? It's going to be $195. So let's put that price here and run this once again. And again, this test is failing. Why is it failing? Because 195 does not deeply equal 195. And this can be a bit of a confusing error. How do you mean? Well, 195 in the body doesn't have any quotes, which means it's a number. Here, 195 is between quotes, which means it is a string. When we're comparing things in JavaScript, a string will never equal a number, even if the value is the same. So in order to get this to work, all we have to do is remove these quotes. And then our assertion will work. Just as well, we can continue also with other assertions. For example, we could check if this is available. So you notice here, I'm grouping multiple assertions under the same test. So maybe later on, we can decide to change the name of the test, but we're just trying to understand how these assertions are actually working. So let's go ahead and assert here that this property is available is actually true. So again, true is a Boolean, so we don't need any quotes. We can put it like this. So the test will continue to pass. Or an alternative way to write this is to still use pm.expect, and instead of writing to equal, we can write to be true. Different syntax, works absolutely the same. If you would think that this is for some reason false, we can write as false, but of course in this case the test is failing. It's a good idea to test our assertions to make sure that they actually work the way we expect them to work. Now there's still one thing that I would like to test here, and that is we have here this Postman collection variable with a product ID, and we manage this somewhere so we can change this later on. So how can we ensure that the product that we have requested by specifying this product ID is also the one that we're getting here in the body? Now, of course, we can check all these properties, the name and so on, but maybe testing out the ID would be a good idea as well. So let's write here pm.expect. So what are we expecting? We're expecting response.id to equal. And what is the name of the variable? Let's go ahead and copy paste this and put it inside here. Okay, maybe we need some quotes. No problem. Let's put this between quotes. No errors. Gonna give it a try. And the test is failing. What is happening in this case? Why is this working here when we're sending the request, but when we're putting this inside our test is not working anymore? Well, what's important to remember is that this syntax only works in the request builder. Essentially, you can use this syntax for variables when we're working with params, with path variables, with authorization headers in the body, anywhere else apart from the scripts. We cannot use this syntax in the scripts. It's simply a string. Postman is not going to replace it. So if we're trying to get the product ID in a programmatic way, essentially from a script, we need to use something similar to the way we have set a variable from the script. So we can use pm.collection variables because this is a collection variable. And this time we're going to use get. We're going to specify, okay, what are we trying to get? Trying to get a product ID. Let's give it a chance. Now there's something even more interesting. You can see now we're getting the value, right? But we're getting this problem that we've seen before when we're comparing a number with a string. If you're looking here inside the collection at the variables, you'll notice that, there are no quotes here. And the question is, why doesn't this work? Well, the thing when we're manually managing information here, most of the time behind the scenes, Postman will save this as a string. And then when we're making comparisons here, then we're going to get a string and we're going to compare a string with a number, and that's not going to work. If we want to rescue the situation and we're pretty sure that we have a string there, we can use a function which is called parseInt. So with parseInt, it's going to try to transform that string into a number, into an integer. So then we can run this and our assertion is working because now we're comparing a number with another number. Now let's go ahead and change this product to some other product. You will see here we are using the product ID. So what we need to do is to figure out another valid product ID. Say, for example, let's disable the category that we have here enabled. And let's simply go with a cappuccino. So we have here this ID for a cappuccino. I'm going to go inside the collection and edit the variables. And I'm going to change here the product ID to a different value. I'm going to go ahead and save it. And let's get a single product. So now we expect to get back a cappuccino. So if we're taking a look at the body, yes, we have a cappuccino. And yeah, the response body looks absolutely fine. Now, if you're taking a look at the test results, they are not so fine. Well, okay, it says here product is a bagel, and we have here some tests that verify some parameters. Well, the thing is, the response itself is still fine. It still looks like a valid response. it just isn't a bagel. Now, we can debate if this is a good test or a bad test, but this for our situation here, this test is overly specific. If there's any change in the data, for example, maybe the price is changing, or the product name is slightly changing, then our test will fail. So the only dynamic part that we have here inside our test are the product ID. And of course, it's always a good idea to assume that the product that we're trying to work with is available. But the name and the price, they are problematic. There are situations like this one where it makes little sense to hard code values in tests. Do we really care if the product is called a bagel or a cappuccino or how much it costs? And in most cases, the reality is we don't. We just want to check if the product that we have received is a valid product. So instead of asserting if a property has a specific value, we can change our assertion to check the data type of that property. So let me give you an example. We know that the response body has a property called name. So let's check if there is a property called name there, instead of just checking it has a specific value. So to do that, we can write here another expectation. So I'm going to remove here bagel. And the expectation that I'm going to write is pm.expect. And the expectation goes against the response because this is the object that contains the product. And we can write here to have property, and the property is name. And for a second, I'm also going to remove this price from here. So now we are just checking if the response has a property called name. And the test is passing. We can check also if it has property called product name. And if we run this, the test will fail because there is no property product name in the response body. We can check that easily. So there's only a property called name. Now, we don't only care that we have a property called name, but we also care if this name property is actually a string. So we can write another expectation, but this time on the property. So we can say pm.expect, and we have response.name, and we can say here to be o, and then as a string, we're going to write here string. So we're going to have here string between quotes. So we're checking if the response body has a property called name, and we're checking that this property is a string. And it is a string. We can also check if it is a number, and this is not a number. It is actually a string. So we're going to get this assertion error. So let's switch it back to string. In a similar fashion, we can also go about the price. So instead of checking a specific price, we can simply go ahead and see here if the response.price to be a number. And the price indeed is a number, so the test is passing. And now from a logical sense, we typically expect our price to be higher than 0, right? So no price can be 0, or we cannot have any negative prices. This is just the business logic that we have. We are trying to make a profit, so we're not want to sell something where we have to give money to the customer, right? So it's a valid expectation to say whatever price we have, it must be at least 1 cent. So it needs to be greater than 0. So we can write here another expectation with pm.expect against the response price to be, and we have here greater than. Always follow the autocompletion to be faster and more accurate. I'm going to write here the price to be greater than 0. The test is passing. Now this product costs $3. So let's change it, for example, to, let's say 4 here. To be greater than 4. And it's not going to be greater than 4 because 3 is not above 4. So we have also tested that the assertion that we have written makes sense from this perspective. Now, of course, we have grouped here a lot of assertions around this test, but we can just also split them. For example, we can write a test that only deals with price to ensure that it has a valid price. We can write a test that just ensures that a property is as expected and so on. So we're not going too much into how we organize this test and how we name things, but we're just trying to understand how we can write these assertions better. And now the advantage of this approach is that we can change the product, and the test will still work. Only if something changes about the structure of the data will we have issues. Now, you notice here that this syntax is relatively easy to read, right? So maybe you don't know exactly how to write everything, but once something is written, you can just look at it and say, oh, response to have property name. That's understandable. Response.name to be a string. That's also understandable. Well, what makes these assertions work so well and be so easily readable is a third-party library that is being used by Postman. So this easy-to-read syntax is made possible by a JavaScript assertion library named chai.js. And you can find out more about chai.js at chai.js.com. And I also linked this documentation in the course notes. So what you will find here are many other options that you can use. Now you'll notice here that the documentation uses expect to equal. So the only thing that you need to get something like this working in Postman is to simply add here pm.expect and it will work in Postman. So let me show you an example here just to understand. We can copy this assertion here, take it inside Postman. If we paste it as it is, we're going to get an error telling us that expect is not defined. So all we have to do is add pm.expect. Getting familiar with the chai assertion library is a very powerful way of writing more sophisticated Postman tests. And this is a very powerful assertion library. So do spend some time and go over the examples that are being listed here. I'm sure you'll find something useful. Let's take a look for a second at the create an order request. Inside this request, we have a few interesting things. When one of these things is here, this variable, which is a Postman generated random variable. It's not a variable that we are setting. However, how can we guarantee that the data that we're sending has actually been received by the API exactly as we intended? Well, let's go ahead and see how we can write a test for this particular use case. We're going to begin with a few basics, and we're going to borrow from one of the previous requests that we have, and this comes from the products endpoint. So what we already have here is this part with response body is JSON. So this is something that's super useful. We want to make sure that the response body is JSON. So we're parsing the response body and storing this in a variable. And of course, once the response body is JSON, maybe we'll also want to set this Postman variable here. But that's not the scope of it. Let's go ahead and write a new test that verifies the customer name. So let's name the test simply customer name. And we're going to have here our callback function. And we can start writing some assertions. So how do we write an assertion? Well, we can go ahead and use pm.expect. And what do we have here? Well, we have the response. And on the response, we have the property customer name that we can use. Perfect. So far, so good. And then we write to equal. And then what do we put inside here? Well, we could try something like this, right? So we could go ahead and put this as a string inside here and see what is happening. And what is happening is that we're going to get a test that is failing. So this syntax doesn't work inside here. It works inside the body, but doesn't work inside here. Still, there is a way to resolve Postman variables like this one inside scripts. The syntax is a bit tricky, but I'm going to show you anyway. So what we need to use is pm.variables.replace in. It's a bit tricky, but hang on for a second. So we're going to replace in, and here we can essentially specify a string, pretty similar to what we have here. So if you're unsure about the outcome of this, we can simply wrap everything in a console.log statement and take a look in the Postman console to see what is happening. Let's clear everything here and run this. So what we'll see here being logged is the result of us writing this line of code. So this is a way how we can still use this syntax with braces without using pm.collection variables that get or something. And when we're working with these random Postman variables, there is no other alternative to reaching one of these values. All right, so you can see here that we are now getting this random Postman variable and it changes all the time. So we can simply go ahead and use this in our code. So we're going to say here pm.variables replace in, and we have our expectation right about here. So let's run it once again, and our test is still failing. And the reason for that is whenever Postman invokes this call, when we say we want to use here random full name or random something else, a new value is generated with every call. So Postman generates one value here in the body, and in the test, it's going to generate a different value. So this is why our test is still failing. We haven't made a lot of progress, have we? Well, not so fast. I have a different idea. I'm going to go ahead and copy this from here. And I'm going to go here in the pre-request script. So here in the pre-request script, what we could do is to set another Postman collection variable. So we can use here pm.collectionVariables.set, and we could call this customer name, and the value would be, whatever comes back from here. And then in the body, we can replace this random variable here with a collection variable, which currently doesn't exist, but it will exist in a second. And also in the test, we can use pm.collectionVariables.get, and we're getting the customer name. So we're letting Postman generate this once, set it in a Postman collection variable, we're using it in the body, and we're using it in assertion. Let's give it a try to see if it works. And what do you see? This is how we can take advantage of random Postman variables and Postman collection variables to pass data between the pre-request, the request, the tests, and so on. Let's continue thinking about what kind of tests we could write against this particular endpoint. So we know that we have the right customer name, and of course there's also other details that we could check. But one interesting one would be this ID. This ID is the order ID, and it does follow some rules. For example, this order ID can only be composed of uppercase letters and numbers, and it has a fixed size of 9 characters. So how can we write a test for something like this? Well, let's go ahead and copy the skeleton for a test. And we can write here something like order ID format. So we're testing the format of the order ID. How can we do this? Well, we can again use pm.expect response.id. And then what we could do here is to write a regular expression. Now, regular expression is a way how you can define in a programmatic way the kind of structure that you expect from data. In this case, we can write a regular expression that says this ID can only contain numbers and letters, and those letters need to be in uppercase, and the size of this thing needs to be 9 characters. We're not going to go into how we can write regular expressions because that's a topic on its own, but we're going to take a look at a simple example at how to do this in Postman. So what we're going to use here is toMatch. So toMatch allows us to write a regular expression, and we're going to write it here, and I want you to pay attention. This is not a string here what we're writing inside match. So a regular expression goes more or less like this. We are starting it here, then we're adding here this caret sign, and then what we'll have here between brackets, we're going to say something like this must contain letters from A to Z and numbers from 0 to 9, and we expect to see this exactly 9 times, and this is the end of the regular expression. You will see here I have no errors. If you're having troubles finding any of these characters on your keyboard, don't worry, I've added this expression to the course notes as well so that you can easily copy paste it if needed. So let's take a look and see if this is working as expected. I'm going to go ahead and click on send. and you see the test is passing. Now, the thing is, I know that this API has a bug, and from time to time in the ID, it will include a character that is not a letter from A to Z or a number from 0 to 9. So it's just a matter of time until you're running this test and you're noticing all of a sudden this test failing because you will find there a character that shouldn't be there. Oh, there it is. Look, have you spotted it? You'll see initially the test has passed, but after a while, we are getting this dash here, and this is not something that we expect according to how this ID should work. So this is why it's a good thing to have a test here that will fail and warn us if all of a sudden something changes about the behavior of this API. It is now time for the third assignment and for you to get some hands-on practice. We have gone through various ways of testing the API endpoints and writing various tests and assertions. Now, I want you to go inside the orders endpoint and take a look at this get an order by ID request. In this case, you're getting here back information about this order, and I want you to use everything that you have learned so far to write some tests. Make sure that you go to the original workspace and fork the collection named assignment 3. Let's continue exploring ways on how we can test this endpoint. So I'm here at the create a new order endpoint, and we are checking that the response body is JSON. We are checking the customer name, and we're also checking that the order ID has the right format. But there's still also other information here. How can we do that? Well, in order to test the response structure, we could again go property by property, check if the property exists, check if the property has a particular type, check maybe other things about those properties. With relatively simple responses, that is relatively okay. But once our responses get a bit longer or are a bit more complex, this approach is no longer so valid. A solution to this is to use a JSON schema and to validate the response that we're getting against the schema. Okay, let's back it up for a second. What is a JSON schema? A JSON schema is essentially a way to describe the structures and rules of our responses. When our responses are in JSON, we can use a JSON schema. A JSON schema is also written in JSON and essentially helps us understand if the JSON that we're having here actually follows the expected format. And it is a bit easier to catch errors in that way. So let me show you what I mean by that. We're going to start with a very, very simple test. So I'm going to use here the test skeleton that we already have. And just one line below, I'm going to write here, schema is valid. And what you will need here is a JSON schema. So we're going to define here a new constant, call it schema. And what we have here is the assertion. So the assertion will be pm.response. And this is going to be one of those special assertions. So we're going to say here pm.response to have JSON schema. And we're going to reference here the schema. So we can simply run it and see if we're getting anything back. Okay, we're getting again the test failed, the failed test because of the ID, which is sometimes inconsistent, but we're going to get here schema is valid. Okay, so we haven't done a lot in terms of this schema. It's just an empty schema, but just by default, it kind of like passes the test. Okay, fair enough. Let's go ahead and actually talk about the body that we have here, about the structure that we have inside here. So first of all, we're going to say, look, we have here an object. This is an object which has properties. So we're going to write here type, and the type is going to be object. Okay, fair enough. Then we can again check, is it still working? Perfect, no problem. Let's say if we say type is array, does it fail? Okay, it fails. It says here, expecting data to satisfy schema, but found following errors. Data should be an array. Our data is not an array, it's an object. Okay, so this is a simple way to make sure that we are on track. Let's continue with properties. So inside properties, which is again an object, we can start defining the kind of properties we have in our body. So for example, ID, client ID, created, and so on. They're all properties. And we can say for these properties, for example, ID is a string. Client ID is a string. Any other information is also a string. So this should be pretty straightforward, but I'm going to go ahead and write here. We have the property ID. And again, as an object, we're going to write here type. And the type will be string. Okay, so we're going to repeat this a couple of times. So I'm just going to copy this code block here. Make sure to add a comma. And do this for maybe 3 or 4 times. Let me make it a bit larger so that you can see it. So we have here ID. The next one on the list is client ID. After this, we have created. After created, we have customer name. And actually, we need another one, but this one is no longer an ID. This is actually an array. So we'll see here products. So we can write here products, column, and also as an object, type will be array. Very well. Let's go ahead and run this. And it seems to be working fine. Now, how do we know if this schema that we have written here is any good? Well, we could essentially go ahead and maybe, again, play around with stuff and see, string, let's change this to a number, see if it fails. And it does fail. Okay, fair enough, seems to be working. But this is a very rudimentary way of testing if our schema works. We need to find a better way. When we are writing tests in Postman, it is our duty to ensure that these tests will actually fail if needed. If we have tests that never fail when they should, then we got a problem, because then our tests will not be so useful and we have wasted a lot of time writing tests that never fail. Now, when we're working with JSON schema, the experience shows that writing a schema that doesn't do what we expect to do is much, much higher than any other assertions we have written before. So when you're writing a JSON schema, or when we're working with JSON schema, we need to be extra careful that what our tests do is actually what we think that the test should do. Now, testing if the JSON schema works as expected actually requires us to make some changes to the response body. Well, this is easier said than done, because this is the response that is coming from the API. We cannot easily make changes to it. Well, luckily, we have a built-in Postman tool that we can use to our advantage. And this is a Postman mock servers. Now, Postman mock servers allows us to create fake API endpoints. So in this context, the word mock simply means to imitate or simulate something. It refers to creating a fake version of the actual API. Let me put this in plain terms. A mock server will pretend to be the real API, provide us with some responses to our requests, but it will not actually process anything. So for example, if we were to create a mock endpoint for this create an order endpoint, that mock endpoint will not save the order, will not do any validation or things like that. Now, the advantage of using a mock server is that it allows us to actually test our tests and to ensure that they work as expected without actually changing the real API, which in most situations we cannot do anyway. So we're going to use this particular use case for mock servers to modify the response body so that we can test our schema. Now, in order to create our mock, the first thing that we need to do is go to the create a new order request and click here on save as example. And what this will do is it's going to save this response body as an example, and this example will be used by the mock. So this is the first step that we need to do. And then the second step is by going over the collection and hovering over it until this ellipsis shows up and from the context menu, we're going to select mock collection. So what we need to specify here is the mock server name. So for example, we can call it Valentino's Coffee API mock. We're going to save the mock URL as a new environment variable. And all we need to do next is to click on Create Mock Server. So the mock server has been created. We can close this tab here. And if we go here over the environments, we'll see here that we have a new environment. This is Valentino's Coffee API mock. So this is the environment that stores information about this mock server, and we have there the address. We can go over these environments and we'll have here this variable URL. We're going to change this to base URL so that it is the same variable we're using in our request. We'll notice here we have base URL, and here it should be also base URL. When we don't have an environment selected, we're going to use the URL that is configured inside the collection. However, when we select an environment, this base URL variable will be overridden, and now we are actually calling using the exact same request without making any changes to the request itself. We're now calling the mock API. So you can notice here, I'm running this once, twice, 3 times, and getting the exact same information back. Nothing changes about this. Now, if we're looking at the test results, we're going to see that a few things fail. Obviously, our mock API doesn't behave like a real API. So for example, where we're checking the customer name, if it is a specific name, that test is going to fail. We also have this problem with the order ID. So this is something that we can change here from the response itself. So if we're going over this example, e.g. here, this is an example. This is what's being used by the mock server. See here, we remove this and click on save. We can check if our test isn't passing. No, it's not passing because it's not long enough. So let's add here a new character. And the schema seems to be valid. So the only problem is the customer name. So let's go back. How can we make sure that this schema is actually a good schema, that it is working as we expect? What could go wrong with this response? For example, what if we don't have the property client ID anymore? How can we simulate this? We go back to this, where we have this essentially temporary response which we wouldn't modify. And I'm going to remove here the client ID altogether from the response. Let's say some developer has removed it from the response and we no longer have it. Will any test say anything about this? And we can run this again. And if we're looking here at the schema is valid. That's weird. How about if a developer would add here a new property? For example, new property, new prop. I'm going to call it hello, just for fun. Adding a new property to the response body. This should definitely raise the alarm. No, it doesn't. Schema is still valid. So now, by using mock servers, we can play around with the response that the server sends us or doesn't send us, and we can then figure out what can we change about this to see if the schema will fail if needed, if one of these situations should occur, if we then have a valid test for that case. Well, it seems that we don't have a valid test for that case. And the problem with this is that our schema is valid, is a good schema, but it does have some problems. And one of these problems is that it doesn't say that these properties are required. So yes, we have defined them in the schema. If they are there, they're going to be checked to be a string or an array or anything else. But if they're missing, that's not a problem. If we add new properties that are not mentioned here, that's not a problem. So for this use case, this is a problem. And this is something that we can easily overlook by looking at the schema and thinking, yeah, it seems to be working fine, when actually it is not. So what we need to do next here is to specify another property, and this property will be the required property. So the required property allows us to specify essentially an array of values that are required. So for example, ID is required. What do we have else? Client ID, it's also required. Created is required. Everything that we have here in the response body is actually required. We need to specify this here so that when we're doing the schema validation, we're also checking that none of these properties are missing. So we now saving this. Let's take a look here in the response. We are still missing this particular property client ID. So let's see if now something is failing. And yes, now we're getting an error and it's telling us data should have required property client ID, but it doesn't. So now we have tested that this particular feature is working as expected. Okay, so let's re-enable here the client ID. Let's save this. I'm gonna check here again that everything is working fine. Schema is valid. Perfect. Let's add here at the end another property. I'm gonna call it new. New. Again, an additional property that appeared all of a sudden in our responses, and we don't know about it. Schema is valid. How can we change this behavior? Well, by default, any additional properties inside the JSON data that are not specified in the schema are allowed and will not cause the validation to fail. While this is useful in some situations, in our particular use case, it's not what we want. Ideally, when new data is added to an API, new fields, something changes, we want to be alerted about this because we might want to check that. We may want to write tests about it. And we don't want to be surprised that something new appeared all of a sudden. So if we don't want any surprises, then we need to specify this explicitly in our JSON schema that we don't allow additional properties. So again, this is another setting that we're going to add here. So just on the same level as type properties required, we're going to write here additional properties, and we're going to set additional properties to false. We don't allow additional properties. And now, luckily, our JSON schema is failing and it's telling us data should not have additional properties. It does have additional properties here. So let's go ahead and remove this from our mock server. And now our schema is again valid. If we need to check back in with the real API, all we have to do here is disable the environment. And then we're going to start interacting again with the API. But using mock servers is a very powerful way of working with a schema, defining it, and making sure that it works as expected. Writing JSON schemas is no easy task, and so far we have just scratched the surface. However, I wanted to go a bit deeper and show you a more advanced example of how we can really ensure that this response body looks pretty much the way we expect it to look like. There are still a few flaws here. For example, we haven't done anything about these properties ID and client ID. They can be anything. In terms of created, we haven't checked for a specific format. And also in terms of the products, we just said there must be an array, but we haven't really looked into like the data structure that these products need to have here. So there's still a bit of work to be done. Now, there are a few things that I wanted to point out. First of all, we can have here a string, but just as well, we can add here another property, which is called pattern. And this pattern allows us to write here a regular expression. Now, this time we're going to write it here between quotes. And in this case, we already have here a regular expression that we can employ. So we're going to simply go ahead and copy it from here and put it here inside a pattern. Now, apart from this, because it is already between quotes, we can go ahead and remove this at the beginning and at the end, the forward slashes. And we can go ahead and save this, but not before we remove this other test, which we no longer need. So let's see if this is working properly. Seems not to be working properly. Let's see why. Oh, actually, this is a good example because now we have a character that we shouldn't have. So we already made the test with this one. Let's run it once again. And now the schema is working. So obviously just by luck, the first request went into one of these edge cases where the ID is not what it should be. Perfect. So we have done this here with a pattern. In a pretty similar way, we can do it also for the client ID. But I want you to take a look here at created. So created here is a date. So what we could do here is write, for example, a format. And we can say the format needs to be date time. So this is a date time format. Let's go ahead and run it. Seems to be working fine. Let's switch back to the mock endpoint just to make sure that in case we're having here something else that it does. So I'm just going to remove the last part of this date time format and make it a bit shorter. Let's see if this causes any issues. And it is going to cause an issue because it's going to say here does not match the format date time. So luckily, again, using mock servers can help us identify if there are any issues at this point. Let's switch back to the real API and take a look at another thing. And these are the products. We mentioned earlier that we have here an array, but we want to go a bit deeper. So we have here an array, but this is an array of objects. And we can actually go a level deeper and say, look, this is an array of objects, and every object in this array must have the property ID and must have the property quantity. So let's see how we can do this as well. Essentially, when we're having an array, we can then specify items. And items will be then an object where we can write additional things. Now, the thing about this is that we're going back to how we define an object. So this is super interesting because you can write here type, and the type will be object. And we can write properties, and we can start writing the kind of properties that we have. So for example, we have here an ID property, and this is type integer. And just as well, we have here a quantity property. Go ahead and copy it from here. And this is of type also integer. Let's go ahead and see if this works. We're getting here an error. Let's take a look. Probably again, the problem with the ID. No worries, we're gonna run it once again. So the schema seems to be working fine. However, you need to remember, this is an object. So we also need to add here required. And we're gonna say here that ID is required and quantity is required. So if any of these are missing, we want to get notified. If you also want to allow or disallow additional properties, that's a different discussion, but let's give it a try with this one. Schema is valid. Gonna switch back here to the mock endpoint and let's change a few things. So I'm gonna make here ID all in uppercase just to give it a try. Gonna save this, gonna select the mock environment, and let's try this again to see if this error is being picked up. And it is being picked up, and it says here should have required property ID. Now we just briefly went over this to exemplify how we can reduce some of the tests that we have written previously and integrate everything in a schema and still get a pretty decent level of testing instead of having to write all these manual tests where we go property by property and so on. Now, as you have seen, writing this JSON schema is not really straightforward. So I must warn you that JSON schemas are a topic on their own, and we are just scratching the surface here. Learning to write JSON schemas is not easy. There are two pitfalls I must warn you about. First of all, and I see this all the time, don't use websites which generate a schema for you from a given response. Most of the time, the schema that you're getting is simply not good. Second of all, you're not going to understand that schema, so it's going to be very hard for you to determine what is inside that schema, what is actually being tested, and so on and so forth. Whatever approach you're taking, always test if the schema will fail if needed. I've seen so many times complex schemas being written that simply don't do what they're supposed to do. And we get this false sense of security because we have this complex schema which is having all these regular expressions and is checking arrays and objects and everything. And then when something changes about the response, the schema says, no, okay, everything is fine. Don't worry about it. Now, if your project is programmatically generating a JSON schema based on its code and given annotation, that is fine. You don't need to write that schema from scratch. You can use it. However, this is not a replacement for understanding what the schema contains and how to test it. So my advice is, if you're just getting started with JSON schemas, is to learn about JSON schemas step by step and to write them on your own. A good resource for learning about JSON schemas is JSON-schema.org, link in the course notes. The website is a bit hard to navigate, but if you spend a bit of time and take a look at the documentation that is available, you will soon get a hang of it and you will see how powerful JSON schemas are. Alright, so you have learned so much about JSON schemas, and now it's time for an assessment. You want to really check how you would apply and create a JSON schema for the getSingleProduct endpoint. We currently have all these things here, but I want you to write a JSON schema based on what you have learned from the previous lectures. Go ahead to the original workspace and fork the assignment number 4 inside your workspace and follow the instructions there. Apart from the status code and the response body, a response also has headers. Now we already know how to test the status code and we know how to work with the response body and make assertions there. But what if there is a header that we would like to test? While headers tend to be very technical, you may find yourself in the situation that you want to make an assertion against a header to make sure that it has an expected value. For example, what if we want to check here if this x powered by header has the value express? So let's write the test for the headers. I'm just going to copy here the structure of the test so that we don't have to write it from scratch. And I'm just going to write here headers. Now, before we actually make an assertion, let's make sure that we can actually get to these headers. And for that, we're going to use pm.response because the headers are in the response dot headers. We'll see here we have the auto-completion for headers. And in order to get a specific header, we're going to use .get. And as a string, we need to pass the name of the header. So it is best if we go here in the headers, select the name of the header we want to use, and paste it here. This will ensure that we don't make any mistakes. Apart from this, let's wrap this up in a Postman console to make sure that we are getting the right value. All right, so I'm going to open up the console, clear it, and let's send this request. So what you will see here in a console is the value express, and this is the value that we need. Okay, so it seems that we have everything that we need. So we can go ahead and write our expectation, which will be a typical expectation that we're going to write with pm.expect. So what are we expecting? Well, we're expecting that this value that we're grabbing from this header to equal express. Let's go ahead and see if it works. And we have here a new test. Headers seems to be passing without any issues. And this is anyway a test structure that we have used in the past, so we know that it is working. So this is how easy it is to test a header in Postman. Can you imagine testing 100 endpoints in just a few seconds? With Postman, you can do exactly that, and I'm here to show you how you can unlock this superpower. Welcome to the third level of our API automation testing challenge. We now have a Postman collection with some requests, and each request has the associated tests. So we can go through the collection request by request, and all we need to do is check if the test passed. Still, this is a manual process, and it is really time to say goodbye to clicking around. In this unit, we'll explore Postman's powerful automation tools that will turn you into an API testing rockstar. We are entering the most exciting part of this course, where all the effort we have been putting into writing this test pays off. So let's dive in. Before we jump into automating things, we need to make sure that the request as it is right now is working without any issues. So what we need to do is to go through every request, send that request, and check here the test results. So we need to do this for every request in this collection, because if we have some issues at this point, then it doesn't make sense to automate this. So we need to check that all the test results are passing. Now, once we have done that, this is when we can talk about the automation. And the first tool I wanted to show you is the Postman Collection Runner. So the Postman Collection Runner is a tool that allows us to run this entire collection with just a single click of a button. So just remember all the work that you did for this just a few requests here. If you have maybe 20, 30, 100 requests that you need to send, that's a lot of work. So we can replace all that with just the click of a button. So let me show you how it works, and it's super, super easy. So all we have to do is go over our collection until this ellipsis shows up. And from the menu, we're going to select Run Collection. This will open up a new tab, and this is the Postman Collection Runner. So let me briefly explain what we're seeing here. On the left-hand side here, we see a list of all our requests. Now, the way requests are executed in Postman is by the order that we have in the collection. So essentially, Postman will go folder by folder and grab all the requests that are inside there, and we'll display them here. Of course, sometimes maybe this is not the way we want to have this, but that's not a problem. We can easily drag and drop requests anywhere else. So we can move requests around if we're not happy with a particular execution order. Apart from this, there can be situations where we say, for example, register a new client. We have already executed that request manually, so we don't really want to automate that, so we can disable that. All right, so this is the order in which this request will be executed. The Postman Collection Runner will execute this request from top to bottom. So it will start with get API status, get all products, and so on and so forth in this order. Now, on the right-hand side, we need to choose how we want to run our collection. And the first option that is already selected is run manually. This is what we want to do. Apart from this, there are also some other settings, but they are not relevant at this point. So all we need to do is click on this big orange run button and start automating this collection run with just a single click. Now look at this magic as Postman goes through all these requests that we have, and in a matter of essentially seconds, the entire collection has been executed, and now we have the results. We know what has happened. So what has happened? We have here all the tests, and we see here passed 11. So 11 tests have passed. None have failed. Now, of course, we can find ourselves in a situation where maybe one of the tests is failing. Of course, we know that this API has an issue, and if we run this a couple of times, one of these schema validations will fail because the ID of the order doesn't match the given pattern. If that is the case, what we will see here is we have how many have passed, and we'll see here failed. Now, generally, we're not interested in how many have passed, but we're interested in why something has failed. So we'll get here information about, okay, create a new order has failed, and we're getting here the reason why this has failed. Now, if we're trying to debug this a bit deeper, we'll notice here that the response is not available. It says here response body is not available. And this is a bit of a bummer because without the response body, we can't really understand what has happened. But we're also given here information that, hey, you can change this in the run configuration, right? So let's go back to the run configuration. And what has happened this time is that Postman has set this flag for us. Persist responses in a session. So by default, for performance reasons, Postman doesn't save the response body. It doesn't allow you to take a look at it and see what has happened. But if we enable this one, it is very powerful because it will allow us to take a look at the response and understand what has happened. Now, there's another setting that I want to show you. And this one is the iteration. This bug that we're experiencing only occurs from time to time. So either we can manually click maybe 3, 4, 5, 6 times through that run button until the error occurs, or we can say from the beginning, look, just run this 10 times, for example, and I will take a look and see which of these times didn't work, and I can investigate that in particular. So let's go ahead and click that run button once again. And you can see here, Postman is doing the heavy lifting for us. Everything is in place. Imagine just the work that we would have to do to run this request so many times and inspect all the tests and see if everything is working well. Okay, so in this situation, we have executed this so many times and nothing has failed. So let's try it again. And what you will see here is that some of our runs have failed. So this is another opportunity to go ahead and investigate what has happened. And we're going to see it is the create new order request that is constantly failing. So that's a good thing that there's nothing else that is failing. But let's this time take a look and see what is wrong with this. Now we'll actually have access to the response and we'll see, oh, look at this character. This is not what we expect according to the schema. This is why this test is failing. So in a nutshell, this is how we can use the Postman collection runner to run our collection with a click of a button. And then if something fails, we can dive into the results and understand what is the reason for the failure. Using the Postman collection runner is the first step that we need to take just to verify that we can actually automate our collection run. So this is going to be probably the first thing that we want to do, just to manually run the collection a couple of times to make sure that everything is working fine. But this is still a semi-automatic step because we need to open a collection. We need to go inside it. We need to open the Postman collection runner. We need to click that button. We need to inspect the results and everything. Now, there is also the possibility in Postman of scheduling a run. So essentially, when scheduling a run, we are no longer executing the Postman collection on our personal computer. We're not using Postman at all. Instead, the execution takes place on the Postman cloud. So there's no need to keep Postman open, or even our computer can be turned off during this process. So this is essentially a fully automated collection run. In order to schedule a run, all we have to do is hover over the collection, click on the ellipsis, and from the context menu, we're going to select Run Collection. By default, we have here Run Manually, but just as well, we can select the option Schedule Runs. So when we are scheduling a run, we are taking our collection and running it in the Postman cloud. In this case, we can also decide which is the order in which we want to execute this request, or if there are any requests that we would like to disable, like registering a new client. Apart from this, on the lower part, there are also a few things that we need to configure. We should give this schedule a name. For example, if we want to run this once per week or once per day, we can decide this here. I'm just going to give it the name Weekly API Tests. And then we can select the run frequency, and this can be like every hour, every week, every day, and so on. In this case, we are on the week timer, so we can decide we want to run it every day, or we want to run it every weekday, because if it fails on a Sunday, nobody's going to be in the office to take a look at the results. Or maybe we can decide just to run this once per week. Now let's say that we want to run it every weekday, and we're going to decide when do we want to run it. Probably early in the morning would be a good choice. Apart from this, we can also get email notifications, and you can also add other people there. There's also some advanced settings that you may want to look into, but they're not relevant for what we're trying to do right now. Let's go ahead and click on Schedule Run. So in this case, we're going to get information about when is this run scheduled. Scheduling is a good way to keep an eye on an already deployed API to see if it is still working as expected. In other words, we are monitoring the API. If there are any issues, this will be reported and we will get a notification. Running this at regular intervals also allows us to understand the time frame when a problem occurred, if one occurs. Now, of course, we have the option of waiting until this collection will be automatically executed, just to make sure that everything is working fine in theory before we wait for the first run. We can manually click on Run Now. But if we don't do this, Postman will do this for us from the cloud. So when we're clicking here on Run Now, this is not the same as manually running the collection on our own computer. Now we are using the Postman cloud to run this collection. Now, instantly we're going to get some information here. We're going to get the information that this is unhealthy, so there's some problems with this API. And apart from this, we're going to see here how many tests have failed and what is going on and why these tests have failed. Now we can notice here a few things. For example, get API status seems to be working fine. Getting all products, get single products, everything works well. Until we start working with requests that have authentication. So we're going to get here the status 403 forbidden. Now, this can be a bit confusing because we have executed this collection locally and it worked without any issues. So why is this failing now? Well, the thing is the following. You need to remember that inside our collection, we have stored a secret. So if we go inside the collection and edit it and jump to the variables, we're going to see here that we have some secrets. We have this API key. Now, the current value, this is what we have here on our computer. However, when we're sharing this collection, and in this case, we're also sharing our collection with the Postman cloud, Postman from the cloud only has access to this information. And as you can notice here, we don't have a valid API key. Now, we can change our workflow in a way that this information is available so that we generate an API key when we're running this flow. Or what's a bit quicker in our situation, we can simply go ahead and take this from the current value and put it here in the initial value. Now you need to be very careful with this because remember, this workspace is public. Anything that is in the initial value is public. For this particular collection, this API key is not so problematic. But you may find yourself in a different setting, and in that case, exposing this API key as an initial value may not be such a good idea. But typically, when you're trying to run a collection and you're having authentication issues when using a scheduled run, but the exact same run is working without any problems when you're using the manual run inside Postman, probably 99% of the cases, this is related to Postman variables. So remember, the Postman cloud is only using this initial value, doesn't have access to the current value. So this is just a small hack to ensure that this is now working properly. So let's go ahead over the collection and we can open here the tab runs. And we can see here that we have scheduled runs. So this is our schedule here. And we can click on view to go back to the previous view that we had. So all we have to do now is click again on run. Wait a few seconds. And we'll see now that our API is healthy, meaning everything that we have inside our collection is working as expected. All the requests are working as expected. All the tests are working as expected. There are no script errors or anything like that. Of course, we can also go into the details and see the test results and see which tests have been executed and the fact that they have passed, but this is less relevant. We also have access to the console log and see if there's any details here that might interest us. But apart from this, there's nothing else that we need to do here. So typically, we are going here when something doesn't work anymore, when we get an alert that our API has issues. Now, this tool can be very valuable for verifying that your public API operates as intended, particularly in relation to configuration updates or recent deployments. So it's just a good idea if you're having a public API to schedule one of these runs and let it run at a regular interval so that you get information about this. If something goes wrong, you will be notified. Now, pre-production environments are usually not publicly accessible, which somehow restricts the usage of this feature. Professional and enterprise plans provide access to a static IP address that can be configured as a firewall exception, but that's a separate conversation on its own. Now, once you have understood how these scheduled runs work, it is also best, once you don't need them anymore, to simply delete them. So all you have to do is, again, go here inside the collection, go to the Runs tab, and then all you have to do is hover over the scheduled run that you have, click on the ellipsis, and either pause it or delete it altogether. So in a nutshell, scheduling a run essentially creates a monitor which runs at a predefined interval and keeps an eye on your API and ensure that it's still working properly. In this lecture, I will introduce you to the Postman CLI, a tool that runs a Postman collection using the command line. We'll learn its basics, setup, and how to use it for a more efficient API testing process. In order to get started with the Postman CLI, again, we're going to hover over the collection until this ellipsis shows up and select Run Collection. From the options available here, this time we're going to select here Automate Runs via CLI. Once we do this, we're going to get instructions on how to use Postman CLI to run this collection. But first of all, we need to install. So let's go ahead and download Postman CLI. To install Postman CLI, we need to follow a few steps. I'm going to demonstrate this process in Windows because most of you are using Windows, but it works in a similar way for macOS and Linux. First of all, you need to open a terminal window. If you never did this before, that's absolutely fine. Simply search for a program called PowerShell. If you are on a Mac, you need to search for a program called Terminal. And if you're on a Linux, you're probably done with installing this by now. Anyway, let's go back to Windows. You will see this window where you can type in commands. Let me make this a bit bigger for you. Now, if we're going back to the documentation, we'll see here that we have installation instructions for Windows, Mac, and Linux. So for every operating system, there is a different command. So for Windows, all you have to do is copy this command. If you have a newer Mac, you probably have the newer CPU for Mac, so you may want to use this first command. If your Mac is a bit older, use this one. And for Linux, you have this command at the end. So I'm going to copy this one for Windows, and we'll have to paste it in the terminal window that we have opened. You can use your keyboard shortcuts or simply click on the window bar and use the context menu to paste. After this, the command will show up, and you need to press the Enter key to execute the command. The installation should only take a few minutes. To ensure that the installation has been successful, we need to type in the following command: Postman -v, and this will print out the current Postman version. Now, when you're seeing this process and all these weird commands, you're probably like, are you sure? Is this a good idea? I mean, why do we need this? Can we go back to this nice Postman interface that we had before? And I can totally understand. A command line interface tool, CLI tool, is invaluable for streamlining the testing process, as it allows for automation, easy integration with continuous integration and continuous deployment pipelines, and overall a faster execution. Apart from this, we can also run a Postman collection on our own infrastructure without using the Postman cloud. Let me put this plainly. If we want to let a computer run our Postman collection without our human intervention, we need to use a CLI tool. If we wish to run Postman tests in a CI/CD server like Jenkins, GitHub Actions, or GitLab, we need to use a CLI tool. We cannot use the graphical interface from Postman. So let's jump back into Postman and try to run our collection using the Postman CLI. Now, if we're looking here on the lower part, we're going to get here instructions about some commands we need to run. And there are essentially two commands. One of them is Postman login, and the other one is a command that will actually run the collection. Now, let's just copy the last command that you see here. jumping in the terminal, I'm going to paste it. And what we're going to get here is an error. It's going to tell us that no authorization data was found and that we need to use the Postman login command. Now, whenever you're getting errors when using these CLI tools, it's important not to just panic because there is an error, but just take a bit the time to read line by line and understand what has happened. So you have executed a command, and then the tool is telling you no authorization data was found. And sometimes these tools, they try to be helpful and telling you, hey, you need to use Postman login. So obviously we have missed something here. We first need to run the first command, which is Postman login. Okay, how do we run this? Let's copy this command here. And we're going to paste it again. And again, we're going to get an error. Now, when we're trying to log in with an API key, in this case, we actually need to provide that API key. And the graphical interface here is trying to help us. You're like, you don't have an API key. How about you add one here? So we're going to click here on Add API Key. And we can either use an existing key that we have, or we can simply click here on Generate Key. We can call this key Postman CLI so that we know why we have created it, and click on Generate. Okay, no spaces are allowed. Let's put this together. And now we have a key, and we can click here on Insert Key. So this key then will be part of this command here. So all we need to do then is to copy this entire command, go back here and paste it. So the first command will log us in, and the second command will execute the Postman collection. So let's see how this will go. So we're going to see here a few issues. But first of all, we have been logged in successfully, and then we can actually see our API here. But then we're getting some errors here. Now, the first error is a type error, and we're going to take a look at the logs to understand what is going on. And the second one is coming here from the orders, and this is probably the schema that has failed in the past, so there's nothing to worry about. So the first error is actually complaining that in the get API status request, we have this console clear function. So it's telling us this is not a function. So obviously, Postman CLI doesn't know about console.clear, or doesn't make sense to have a console.clear in this context. So we need to figure out a way around that. And the second assertion error is that schema is valid. But apart from this, this is how we can run a collection using Postman CLI. And we can take a look here and see all the requests that have been executed. We'll have here essentially a report at the end, so we know how many requests have failed, how many requests are still working, and so on. Let's jump back into Postman and try to fix this console.clear problem. So what we can do here in the status request, get API status. And in the pre-request script, you see here we have console.clear. So what we could do here is we could add an if statement. So if console.clear, without actually calling it, and we're going to move the statement inside here. We can quickly verify if the console is still being cleared. Let's send this request. So we see console was cleared. We have saved this request. And then if we need to run this once again, all we need is the second command, because Postman has logged us in. So when we're trying to run any other commands here, we don't need to log in once again because we are already logged in. So all we need to do is use this command Postman collection run, and this thing that we see here, this is actually the internal ID of the collection. This is how Postman identifies our collection. And now we have apparently got rid of that issue with console.clear, and we still have this problem with the schema is valid. Now, apart from this, we're also getting information that this execution has been uploaded to the Postman cloud. So what does that mean? Well, it means that we can see this detail inside Postman. Let me show you. If you go back to Postman and click on our collection, we're going to see here the runs tab. And what we'll be able to see here are past runs. And we have here the source. So we have here the source being Postman CLI or runner, which means the manual runner that we have used. And we can also dig here into the results and see what is going on. So for example, we're gonna click here on this icon to view the report, and we can take a look and see what exactly has failed and hopefully what is the reason for this. And of course, if you need to troubleshoot this, we can go back to either running the request manually in Postman or using the manual collection runner to run this collection from the beginning to see if whatever error we have encountered is still occurring. Now, as you can see, the response body is also not available, so this is something that we need to change in the run configuration. But for Postman CLIs, this is not something that we can do at this moment. So this is why we need to run this manually to see if we can replicate that specific issue. When you're using the Postman CLI to run a Postman collection, there are actually a lot of things that you can configure that are not visible here directly in Postman. Now, to understand how you can use Postman CLI like a pro, it is important to spend a bit of time and go over the Postman CLI documentation and its command options. Essentially, whenever we're running a command like Postman collection run, we can also specify some additional options that change the behavior of this command. Now, there are a lot of options here, and I highly recommend going over them and seeing if you may want to use them sometime in the future, at least to know that they are available and that this is possible. However, there is something that I wanted to show you just to give you an idea on how we can use this. Let's say that in our collection run, we only want to run a specific folder. And for this, we can use this option, -i, and specify the folder name. Let me show you how it works. So all I have to do is go back to Postman, and let's just copy again only the command that runs the entire collection. In Postman CLI, I'm going to go ahead and paste this. And after this, I'm going to add here a space, then -i. And then between quotes, I'm going to put here a name of the folder that I want to execute. For the sake of this, let's just say I want to execute status. So only the requests that are inside status, I want to execute them. I'm going to write inside here status. Let's go ahead and run this. And what you will see this time is that only one request has been executed, because now with this additional option, we have configured the way this collection run functions. So only one request has been executed. And this is sometimes very powerful because we can decide to run only a couple of folders. So for example, if you need to run only 3 folders from a collection, then you can just use -i, the name of the folder, and then after this, also the other folders. So let me give an example. Let's say we want to run status, and then there's another folder that we want to use, products. I'm going to write here products as well. And you will see here that only status and product as folders have been executed. Again, it's super important that you go over the documentation and understand what these options do and how you can use them. Welcome to the last level of our API automation testing game. In this unit, we'll be tackling the integration of Postman tests in CI/CD. In the upcoming lessons, my goal is to help you understand why this is important and how to do it. Integrating Postman API tests in a CI/CD pipeline is essential because it automates the testing process, ensuring that APIs are continuously validated and function as expected during development and deployment. Let me put this in simpler terms. We're basically firing ourselves from the testing department and letting computers take over while we still keep a watchful eye to make sure nothing goes haywire. We will kick things off by discussing the fundamentals of CI/CD and the importance it holds in our testing process. Next, we'll embark on a step-by-step journey to run Postman tests using GitHub Actions, one of the leading CI/CD tools out there. If you're using a different CI/CD solution, that's also fine. I will provide you with some guidance on how to get started with other tools as well. Apart from this, we will talk about Postman workspaces, reports, and effective collaboration techniques within your team. If you have been following along on this grand adventure, give yourself a hearty pat on the back. This is the fun part, so grab your gear and let's dive in. Let's talk about CI/CD for a second. CI/CD stands for Continuous Integration and continuous deployment. It is a practice used in software development to make the process faster and more reliable. With continuous integration, every time a developer changes the software, those changes are tested automatically. This helps catch any problems early in the process. Once the CI pipeline is done, we start the CD pipeline, where we typically deploy the software to a test environment, which allows us to do further tests. If all tests pass, the changes are automatically deployed to the production environment and go live. This practice allows for improvements that can be made quickly without having to wait for a big update. This process helps teams work together more efficiently, and it makes it easier to keep the software running smoothly. Now, what does this have to do with Postman tests and automation? Well, the thing is, if we're working on an API, using CI/CD makes absolute sense. And we also want to integrate our Postman API tests in the CI/CD pipeline. There are at least 2 steps in the process where it makes sense to run Postman tests. After deploying the API to a pre-production environment, such as a test environment, and after deploying to the production environment. Using the Postman CLI allows us to run a Postman collection and the associated tests in our continuous deployment pipeline without us manually triggering a run. Let's talk for a second about CI/CD providers. Using a CI/CD tool allows us to automate the process of integrating code changes, testing, and deploying applications, making our lives easier. Now, it is important to understand that there isn't a single best tool for CI/CD. The best tool for you will depend on your specific needs, your team's familiarity with the tool, and the specific requirements of your project. Your organization may already use a tool, so you could be forced to use whatever option is available anyway. Some popular solutions for CI/CD include Jenkins, GitLab, CircleCI, and GitHub Actions, among others. In the upcoming lesson, I'm going to show you how to use Postman CLI to run a collection in GitHub Actions. Now, I want to make it clear that this isn't intended as an introduction to GitHub Actions. We're focusing here on how to use Postman CLI within the context of GitHub Actions. If you are not familiar with GitHub Actions, that is absolutely fine. I will take you through the process step by step. Now, you might be using a different CI/CD tool, and that's perfectly fine. The beauty of Postman CLI is that once you understand how to use it, integrating it in any CI/CD server is relatively straightforward. The principles we'll cover here can be applied to other CI/CD tools as well. Before we start, you'll need to sign up for a free GitHub account if you don't already have one. GitHub Actions is a feature of GitHub, so you'll need to have an account to be able to use it. Signing up is relatively easy and quick, and it will give you access to a wide range of tools and resources beyond just GitHub Actions. So let's go ahead and run Postman API tests with GitHub Actions. For that, we're going to need a GitHub repository. So let's go ahead and create a new repository. I'm going to name the repository My API Project. And also want to make sure that this repository is public. Let's go ahead and click on Create Repository. In order to configure a pipeline with GitHub Actions, we need to go here from the project page to Actions. And we're going to set up a workflow ourselves. Essentially, a workflow is something that we want to execute with the help of GitHub Actions. I'm going to call this workflow Postman. And here we will have to put in the configuration that is needed to run our Postman collection using Postman CLI. Now, luckily, we don't have to write everything from scratch, but we have Postman on our side to help us with this process. So what I'm going to do next is I'm going to jump here inside Postman, hover over the collection, and select Run Collection from the options. Then I'm going to go to automate runs via CLI. And what you will notice here on the lower part of the screen is run in CI/CD. This is a bit hidden, and I wouldn't be surprised if you missed this before. So let's go ahead and click on configure command, because with this tool here, we'll be able to configure our pipeline in just a few seconds. So first of all, we want to make sure that we have the right collection here. And then from the list of CI/CD providers, we're going to select GitHub Actions. And what we'll see here is the command that we need to execute. So let's go ahead and copy this command. I'm going to jump back to GitHub Actions. And here in this window, I'm going to paste this. Now this is a Git repository, so we need to commit these changes. And we can just go with the defaults here and click on commit. So now our project contains a folder which is .github/workflows. And inside here we have our configuration file, and this should run our Postman collection. If you want to see what exactly is happening, we can click here on View Runs, or we can simply go here to Actions. Now if we take a look at one of these workflow runs here, we're able to see if they were successful or not. So in essence, we have here a job which is called Automated API Test. We can go on it and we'll see it is red, so it's already not looking good. But when something doesn't work, it is important to understand what has happened. So you'll see here there are various steps that are happening. Setting up the job, running something, and then this is the part that is interesting for us. It is installing Postman CLI because it is not installed. So you'll see here, okay, Postman CLI has been installed. This worked without any issues. And then it's trying to log into Postman CLI. And it's going to tell us, hey, there's some argument missing here. So again, we haven't specified the API key. And what we definitely don't want to do is to put that API key inside our code. So we're not going to put any keys in our configuration. So how can we handle this? Well, if we're looking back at the configuration, we're going to see here that there is something that is referencing an API key. So let's open up here postman.yaml. And what you're going to see here is something with secrets.postman_API_key. Every CI/CD system out there will allow you to store some secrets. So let's go ahead and do exactly that. I'm going to copy here postman_API_key and go to settings for this project. And then under security here, you should see secrets and variables. So we're going to select from the list actions. And this allows us to define a new repository secret. So let's go ahead and click on new repository secret. We're going to give it this name that we have just copied from the pipeline. And then from Postman, we need a secret key. So from here, from Postman, we can see here again the option of generating an API key. And this time we're going to write here GitHub Actions. And this is very helpful because then we know that this API key is associated with GitHub Actions. So we can simply go ahead and copy this entire thing and paste it here and then click on Add Secret. Now I'm showing this openly because I'm going to revoke these secrets later on, just in case you're wondering. But I want you to understand exactly how this process works and how these secrets look like. It's also important that you name them exactly as you see and that you don't add any spaces or any other characters, new line and things like that to them. Otherwise, they tend not to work so well. Let's go back to actions here. And we can take a look at one of these runs that has failed here. And we can simply click on this button, rerun jobs. So this will essentially restart these jobs. So now the job has started. And we can even click on it to see what it is doing. And we can see the installation part is done. It has logged in into the Postman CLI. So we have that information there. And then now we're running some API tests. And we can see here what is going on with API tests. And we have the exact same report that we see when we're running Postman CLI locally, but this time it is running in the cloud. Now, whenever something goes wrong with this, you need to determine, is this because there was an issue executing the Postman collection? So essentially a Postman test has failed. Or is it a problem with a script that we have written? In any case, it is important to have the patience to go over the logs and understand what has happened. If there are some errors, it's important to understand if there are any hints or any information here in these logs. So don't get scared that you see some failures here. That's absolutely normal. We actually want to make sure that whatever we're doing here actually fails if they need to fail. Just as running Postman CLI locally, when we're running Postman CLI with the help of a CI/CD provider like GitHub Actions, the results of this execution will be published to Postman. So we can go back inside Postman, and if we close these tabs and click on the collection name itself, we'll see here runs. And this time we're going to see again information about the run that just happened. There are also additional informations here. So you can see here, this is the second build. This is being linked actually to GitHub Actions. So we can click on it and see more details about this, what has happened, why something has failed. But just as well, we can also visualize the results that we have from within Postman. I hope you have managed to follow along, because now it's time for another assignment. It is super important that you understand how to use Postman CLI, and if you manage to run the API test with the help of GitHub Actions, then essentially your job is done. If you haven't done that, please go to the previous lecture and try it once again, because for this assignment, you will need your GitHub repository and you will need to submit your GitHub repository in order to be able to complete this final assignment. Anyway, go to the original Postman workspace, work the assignment number 5, and follow all the details that you will find inside there. If you're not using GitHub Actions, that is also absolutely fine. You can run Postman CLI in virtually any CI/CD system out there. However, for the most popular ones, Postman makes your life a bit easier. So when you're going here over your collection and selecting Run Collection, then automating via CLI, and then under Run on CI/CD, you click on Configure Command, what you will see here are different CI/CD providers that you can use. So you have Bitbucket, Pipelines, CircleCI, GitLab, Jenkins, Azure Pipelines, Travis CI, and probably many others in the near future. Apart from this, you can also go and select the operating system where this provider is running. So if there are any particularities, if you know that this is running, for example, on Windows, then you can also select the operating system there. And what you will be given here is the configuration that you can use to get started with this. And this, of course, changes depending on the provider. But for most situations, this is just enough to get started, just enough to see that these tests are executing in your CI/CD pipeline, and then you can make improvements based upon this. But in a nutshell, what you need to do is you need to ensure that Postman CLI is installed. You need to make sure that you are authenticated and that you don't expose your API credentials anywhere in the pipeline configuration. And then you need to run the Postman collection run command, specifying the ID of your collection. And after this, the results of this execution will be displayed in your CI/CD system and will also be ingested into Postman so that you can see the reports from the collection itself. Postman is all about collaboration. Most of the time, when you're using Postman, you want to collaborate with other people in your team. For that, you need a team and you need to use team workspaces. So in order to create a team workspace, all you have to do is go here to Workspaces and click on Create Workspace. Next, if it's not already selected, you need to select here Team. So let's call this workspace My API. My account doesn't have a team, so a team will be created as well. So let's go ahead and go directly to the workspace. And let's see what we can do here. Team workspaces allow you to collaborate on a collection. You can create forks, essentially, which are a copy of a collection. When you're working on a collection and making changes, of course, you can also collaborate with others and comment and have conversations with others within your team to understand why some changes are made or why maybe something isn't working as expected. And you're also able to track everything that is going on within your collection, knowing exactly who has made which changes and most importantly, why. when you're working with many APIs, it's also super helpful to be able to search around and to find what you're looking for. Okay, so let's go ahead and see exactly how we can benefit from these team workspaces, and especially how we can benefit from forking collections and merging changes into them. So let's go ahead and switch back to our dark theme. And I'm going to make this a bit bigger for you so that you can properly see. We're going to go ahead and create a new collection, and I'm going to call this collection Postman Echo. So let's imagine that we want to collaborate on this collection, but we don't want to make changes directly to the collection. In that case, what we can do is hover over the collection until this menu pops up, and then we can select Create Fork. So then we're creating a fork of this particular collection, but receiving it in the same workspace. So this will be my fork. We can give it any other label. For example, we can call it new request, because let's say we want to work on a new request. We're going to fork this collection. We're going to have an exact copy of this collection. And in this new collection, we can go ahead and add a request. And let's say, for example, we want to add a request to the following endpoints. So we're going to use postman-echo.com/get. So this will be a very simple request against this API, which is provided by Postman. And we're going to get here some information back, not so relevant. Just going to go ahead and save this and close this. So our original collection doesn't have any request. Now we have added a request here. Just want to test it a bit to make sure it works. And we'll say, okay, now we want to integrate these changes back into the previous collection, because we know that everything what we've done here, adding the collection, maybe writing some tests and other scripts, everything works as expected. What we can do is we're going to go over our fork, and from the context menu, we can do two things. We can create a pull request, which essentially is a request for merging these changes back into the original collection, or simply merging the changes. Now, of course, this depends on the permissions that you have. Sometimes you can merge changes, but sometimes you can only create a pull request. So let's go ahead and do that. So with a pull request, we have to provide here some information like why are we making these changes to the collection. So for example, you can say that the title is added request, and we can provide here a description like we have added another request, which is necessary for whatever project we're working on. We can also add here reviewers from our team, and then we can go ahead and create that pull request. So we can see here a few things. So we'll be able to see exactly what has been added. So we'll see it's a new request. It is with the method get, and this is the URL where this request is going. So here you'll be given an overview of everything that has changed in that collection. And it's important to notice here that we are having this particular source with a label that we have specified, and we want to integrate these changes in the original collection. So this is the original collection. This is the one that we have forked. Now, depending on how things are configured, we may or may not have the permission to merge. In this case, we do have the permission to merge. So this merge button appears here. So we're going to go ahead and click on it. And here there are various options that we can consider. Essentially, once we merge these changes, we don't need the copy that we have made, the one with the label. So in this case, I'm going to select merge changes and delete source. But you can just go ahead and click on merge changes and manually delete it later on if you feel more comfortable. So let's go ahead and click on merge. So the pull request has been merged. So the changes that we have proposed are now inside this collection. In a nutshell, this is a very simple workflow that you and your team can use when working on a Postman collection in a collaborative way. And you want to keep track of which changes are being made and, most importantly, why. We are coming towards the end of the course, and it is time for you to claim your Postman badge for completing this course and doing all those assignments. Now go to the original workspace and fork the collection named Claim Your Badge. Inside there, you'll find detailed instructions on what you need to do in order to claim that badge. I hope you have been able to follow along and do all the assignments. If you need any help or you got stuck, please refer to the course notes for every individual assignment. Congratulations! You reached the grand finale of this API test automation course with Postman. Give yourself a pat on the back or even a round of applause. Yes, because you have earned it, my friend. I hope you had as much fun learning as I did teaching. Sure, it was a bit of work, but who says we can't enjoy a little brain workout, right? API testing and automation with Postman can be a bit of a maze, but I aimed to guide you through this as smooth as possible. Of course, some things just couldn't fit into the course, but don't worry, the course notes for this lesson have got you covered with both free and paid resources to help you continue your Postman journey. Just like you, Postman and APIs are constantly growing and evolving, so make sure to keep up to date in this ever-changing world of API testing. It was a pleasure having you throughout this course, and I can't wait to see many of you proudly wearing that Postman badge on social media. And when you do so, don't forget to tag me, it will make my day. If you enjoyed this course, I'll be thrilled if you could check out my YouTube channel for more amazing content and smash that subscribe button. Your support will keep me fired up to create more content like this one. And while you're at it, please show some love to the sponsor of this course, Postman. With that, I just want to say a massive thank you for joining me in this adventure, and I hope to see you again in the next one. Until then, happy testing with Postman!